Christ, they're living for Christ.
Radio TV Phono Nut here, and for those of you who have noticed the lack of in-depth videos from me over the past several months or year or 2 years or however long, well, I've got a doozy for you today. This is the radio from Hades. This is about a 1955-56 cheaply built General Electric 5-tube AC/DC radio. I bought this cheaply off of eBay, and they mentioned that it had a Bluetooth module added and that it worked great. Well, the radio showed up, and I wouldn't exactly call it working great. It would pick up the strongest local stations if you turn the volume all the way up. You might could hear it in a quiet room, which we'll demonstrate shortly. So I pulled the chassis out and discovered that someone had done a very sloppy, ranks right up there with one of the worst box jobs that I've ever seen, recap and re-resistor job, and they did a very sloppy Bluetooth module installation, which I have removed at this time. In fact, the work was so bad that it could have caused safety issues. So we had to undo all of that sloppy repair work and make it look a lot neater. We removed the Bluetooth crap. The IF transformers both needed to be rebuilt, even though they had been replaced at some point in time, but they were defective again. The 50C5 audio output tube was very weak, and the couplet in the audio circuit was defective. So with all of those problems with audio deficiencies and bad IF transformers, it's a wonder this thing was even receiving it at all. So as far as the Bluetooth module and the work that was done, I'm inclined to believe that whoever worked on this was not proficient at troubleshooting. I think they probably knew enough to take their own meter and check the resistor values based on the 2 or 3 resistors that were original, that were left in here, that were still of the correct value, but I don't think they knew much of anything else. And to compensate for the audio deficiencies, they wired a 3-watt stereo amplifier in between the output of the Bluetooth and the volume control input of the radio, and I'm sure that sounded very bad. So I won't spoil it too badly for you, just sit back and watch. But on another note, we're using a different camera today because for some reason the nice Kodak camera decided to take a dump. I don't know what happened. I was in the middle of doing a video with it, and it was working great. I turned it off. I turned it back on. The only thing that would happen was the backlight for the viewfinder would light up and the camera would not turn off. The only way I could get it to turn off was to remove the batteries. So I thought, well, maybe the batteries are getting low, because these electronics will do weird things when the batteries get low. So I charged the batteries, and that still didn't do the trick. So I just set the camera to the side for the moment, and I'll play with it some more later and see if I can get it to behave. But right now we are in pretty good shape for cameras. I've since, well, I had the old camera that I used for years, that's still here. I've got this Canon camera that we're using now. I have an Olympus camera that was in a box of junk, and then I have a better Canon camera that a friend just gave me. So I think we ought to be in pretty good shape for cameras right now, but I would like to try to figure out what's up with the Kodak and get it going if I can. But until that time comes, we'll just use what we have on hand here. But anyway, our radio is working
those lines. And every
well
year
now.
for the last I take 5 to 8 men a year, and you're one of those guys. God put you on my heart.
And that's not an image. That's 1390 and 1010 running the same religious programming. And as far as sound quality, 1390 sounds a bit brighter than 1010, and 1390 would sound okay if it didn't have this crap in the background. 1450, that's the sports station. It's a bit weak and has that background hum.
There's at least 20 to 30 men a year for 50 years that I just intentionally...
Overall, 1010 probably has the best sound, and it could be better. And 1010 is the only one that doesn't have an FM translator.
Around it. What do you say to those guys out there?
So the other stations probably really don't give a crap what the AM sounds like. They just want to have something to keep on the air to satisfy the FCC requirements to keep the FM translator going. Although there's been times 1390 went down for extended periods and the FM translator kept going, so...
Where's a good place for somebody like that?
Okay, this video is going to be a very lengthy one, so I won't keep rambling on during the introduction, but sit back and enjoy. We have a GE 5-tube AM radio from about 1955, 1956. And years ago I had the white version of this, the model 466. This is a model 465. And I always liked how the dial light was attached to the pointer, and it tracks the pointer, only illuminating the section that you're tuned to. Now, this radio plays, but it does not have very good performance. I've got the volume wide open, getting some kind of interference there, and I think I know what it is, and I'll show you in just a minute. That's on a local station. That's as loud as it gets.
Hey, Environment Masters. Free plumbing, electrical, and AC.
1010's a little better. More of that interference at this point on the dial.
This message is brought to you in partnership with ADA 8.
Interference there. Like I said, it plays obviously, but it's not as perky as it should be. Now, someone has been in this radio prior to me, and they replaced all of the paper and electrolytic capacitors and most of the resistors, and they added a Bluetooth module to the existing circuit. Now, I know that's a popular thing to do these days. I get the fact that in most areas content on AM is often lacking, so people want to come up with a more modern way to utilize their old radios. I understand that, and I'm not going to knock anybody who chooses to add such an option to their radios, but me personally, I don't have anything that transmits a Bluetooth signal. I'm not looking to get anything that transmits a Bluetooth signal. And quite frankly, I really don't like adding things to an old radio that wasn't there originally. If I want a Bluetooth speaker, then I'll go to China Mart and buy one. If I want to play something through an old radio that doesn't have a phono input jack on it, then I'll just use a small low-powered transmitter. And then that way the radio doesn't have to be modified, and if our transmitter has enough power, we can transmit to every radio in the house, it will. Alright, let's get this open and see what the inside looks like. Alright, so we have our switch on the back. Radio center is mute, which is, this is just a center off switch. And then the other way is Bluetooth enabled, so all they're doing here, when it's in the center, it just leaves the line to the audio circuit open. When it's in radio, it connects the output of the detector into the volume control, and then when it's in Bluetooth, it connects the output of the Bluetooth module to the volume control. And this does look kind of sloppy. This white thing here looks like possibly a 5-volt USB power supply, and if that's what that is, that could definitely be hindering our AM performance. And then we have this board here attached to it that looks like the Bluetooth module. This looks like some Bluetooth amplifier that somebody modified to stick in here, and I'm not sure what this other little board is on top here with the integrated circuit on it. Now, I think probably the neatest Bluetooth conversion that I've seen was a very high-end, very fancy Stromberg Carlson console that Mr. Carlson's Lab featured on his channel, and he went all out with that one and made it look very neat in the process. And it wasn't this kind of slop job here with silicone and zip ties. On that particular radio, he was actually able to design a switch into the mechanics of the radio, so when you tune the set to the end of the dial, it clicked the switch into Bluetooth mode, and then whenever you turn the switch, the dial backwards, it engaged the switch back into radio operation. And he designed a little circuit board with some solid state devices and a relay on it that not only switched the audio from Bluetooth to radio as needed, it also cut the B+ to the front end circuits of the radio whenever the radio was switched into Bluetooth mode to prevent any leak through from the radio. So that right there, like I said, is probably the neatest and most comprehensive Bluetooth conversion that I've seen. But like I said, for my purposes, I would have no need for something like that. But if you have a need for something like that, then knock yourself out. Then just try to be neat with it. So I'm going to open this up, and we're going to try to figure out how they have this wired in and what all this is, and then we're probably going to delete it, especially if I determine that this is what's causing our performance problems. Now, the IF transformers at some point in time have been replaced with Miller parts. I don't know when that was done. That might have been done 60 years ago. It could have been done when whoever worked on this recently was in here. I don't know. I don't know what kind of condition they're in. Hopefully they're good, but they may not be. The earlier versions of this radio had a big long ferrite rod antenna affixed to the back cover. This one here has a smaller ferrite rod antenna attached to the chassis. I'm trying to remember what mine had. We're going back 30-something years. I think mine had the smaller antenna attached to the chassis, which means it's probably a slightly newer radio. And knowing how GE likes to cost cut, they probably decided they could save a little money by using this smaller antenna. Now here we are with the bottom panel taken off. Now I can't completely remove it because they ran the wires for the Bluetooth switch through one of the holes there, but you can tell that when this radio was made that GE was starting to go down the toilet in terms of build quality. And we can see that whoever worked on this was a bit sloppy. Okay, so our white wire here is coming off the center of the switch to the input of the volume control, and then we have this wire going to one terminal on the switch coming out of this cable here. This is our Bluetooth audio wire going into the switch, and then we have this yellow wire here. It's attached to the IF transformer going over here to the switch. That should be our radio's audio. So when it's switched into radio, it switches the yellow wire into our volume control like it would have been from the factory, and then when we switch it to Bluetooth, it switches the output of the Bluetooth into the volume control and disconnects the radio input. And looking at these filter capacitors, that looks kind of sloppy with liquid tape insulating the connectors there, and blobs of looks like silicone. Okay, I have the GE radio circuit disabled, just the Bluetooth is active. I did that by pulling out one of the tubes. Now I'm going to turn the GE on, which will enable the Bluetooth module, and we have our Zenith transistor radio sitting right next to it, which will simulate basically it being close to the loop antenna in our GE. Now take a listen whenever I turn it on. Hear that? So yeah, if that Bluetooth module, that Bluetooth arrangement is emitting crap, and you know what that means. That means it's got to go. Because I want to be able to use this. I want to be able to use this as it was intended. And it sounds like this thing is transmitting a voice that's being picked up over our Zenith. Yeah, I believe it is. Yep, Mr. Bluetooth has got to go. It's long overdue for a dental appointment. Alright, waiting on it to warm up, and we'll see what it does now.
I can remember in a while. This is a very good match.
Alright, it still does not have the sensitivity and the volume level that I'm looking for, but it does not have that interference over various portions of the dial.
So many times.
Because we dissected all of the NBA games as much as we can.
Now, the biggest mistake I see that they made in this is that in this set, the Bluetooth module is active, whether the switch is in the radio or the Bluetooth position. And if you're going to do something like this to a radio, you need to arrange it, figure out some sort of way to where when the radio is in normal standard broadcast position, that the Bluetooth module is not receiving power, and that way it won't be emitting interference that could obliterate the AM broadcast band. Now, going back to the big Strongberg Carlson that Mr. Carlson added a Bluetooth module to, that one he fixed. So when he tuned the radio to the end of the dial, it activated a micro switch which applied power to the Bluetooth module and applied power to another circuit board which transferred the audio source from radio to Bluetooth, as well as disconnected the B+ voltage from the front end stages of the radio. If I remember correctly, I probably should go back and watch the video before I make an idiot out of myself. And the one he did, like I said, is the nicest conversion of anything I've seen, and his radio has the audio amplifier and the speaker system to back it up. No, this little GE is not going to sound horrible, but at the end of the day, it's still a cheap radio with a little cheap 4-inch speaker in it, and it's not going to sound all that great. So in other words, in my opinion, it really wouldn't be worth the trouble to make the conversion to. I mean, yeah, I get it. It would be cool to listen to 1950s and 60s rock and roll over something like this. You don't know how bad I wish we had an oldies station that still played that, but to me that's a lot of work on such a low-end, cheaper radio. And if you wanted to do that, like I previously said, you'd be better off to get a little AM transmitter like that little $30 thing that I did the video on a while back, and place it next to the radio, and then you can play your device through the transmitter and just receive it through the radio, and no modifications have to be done. My only gripe with that little $30 transmitter is the range is terrible, but I'm going to try to do something about that one of these days. But for a $30 transmitter, it's not bad. But anyway, let's get this thing back apart and start ripping all that crap out of it and getting it converted back to normal. And then we'll try to figure out why the sensitivity is in the toilet. I wouldn't be a bit surprised if somebody didn't misalign it on purpose to try to cut down on the interference, maybe. I guess maybe they were happy just to receive their local station somewhat faintly, but I want it to work as good as it's capable of working as a radio. We don't need anything else added to it. And someone also replaced this control at some point. How do I know that? Because the shaft is a bit loose, the nut's not as tight as it could be, and this shaft is a different color than the tuning shaft. And based on my memory, I believe these originally had a pull-on switch rather than a turn-on type switch. In fact, I'm so sure of myself that when I first plugged this in, I pulled the knob to turn it on and it wouldn't pull. So, in this shield wire, they didn't even solder this onto this lug on the volume control that's meant to be used as a stop to go through a hole in the chassis to keep the control from rotating. There's another stop down here that'll serve the purpose. We can just break that stop off right there. It's not needed. And here it is. And yep, somebody took one of those cheap square USB chargers, cut the front off of it, wired the AC in directly, and then attached a cable to the USB output to the Bluetooth circuit. So not only do we have interference coming from the Bluetooth circuit that could get into the radio, we have interference coming from this cheap Chinese battery charger, USB power supply thingy. Now, I'm not going to throw this away. We might find a use for it one day, but yeah, this was, in my opinion, pretty shoddy. Alright, anything related to Bluetooth has been removed from the radio. It should be wired back like it was from the factory. And the most time-consuming part was removing all of the silicone that held this switch in place, which will come in handy the next time I decide to convert a cheap modern-day 2-speed turntable to 3-speed. We can have center for 33, the 1 position for 45, and then the 2-line position for 78, if I don't lose it first. And I whacked off the little tit on the volume control to where it will fit flush into the chassis and not be wiggling around. Okay, we're back together for now, and it does work better without this crap in there, but it could stand to work better than it is.
See, every one of us are without excuse. Everyone. Going for a pin, nope, he kicks out. Pin ballot kicked out. I thought maybe Breaker was going to win that there. He said Dominic Mysterio.
I can tell our dial tracking is off.
Motion getting guys.
That ought to be coming in about right there, maybe. Yeah, the dial pointer looks right. I'm thinking probably what this needs more than anything is an alignment.
Both Roman Reigns and CM Punk.
And of course I want to clean up the previous person's repair work. I don't like some of that sloppiness.
If he gets this one right and Dom wins the Intercontinental Championship, he must.
Well, I'm out here getting ready to do some troubleshooting, and now the sensitivity is even worse. Now I've had to touch the loop antenna to even get anything to pass through. Alright, I'm blasting a 455 kilohertz signal through here, and with the radio tuned to 910 it gets it because that's a harmonic, a 455, but whenever I tune to the top of the dial I'm not getting anything at all through this, so that leads me to believe that this IF is majorly misaligned, whether it's due to somebody in here twiddling with it or whether it's due to capacitors within the IF transformers that have drifted. Now I have my signal generator through a .001 capacitor going into the grid of the IF amplifier tube, and as you can hear the signal is much louder there than it is at the front end, so we obviously have a problem in our front end stage. Now let's decrease our signal generator output. And I'm going to attempt to try to peek out this second IF transformer. Let's see. See if this does anything. No, that's not really doing much. Alright, let me try the top core. Nope, those IF transformers are not doing much at all. Well, I guess whenever I was clipped to the front end, my clip lead wasn't making good connection, because now I'm getting a very loud signal through, and I've got it turned down now because I'm going to try to peak this first IF transformer. Okay, there seems to be an issue with those IF transformers because I'm not getting a peak. It's very, very, very broad. And whenever I tune through a station, that's evident too. It's not a very... This radio doesn't have very sharp tuning, or not as sharp as what it probably should be. And just to show you how much more efficient these older speakers are, I have the radio clipped to the one inside of the cabinet, and it's louder than this little TV speaker here, which right now I need louder. And I'm feeding an audio signal into the radio, and the amplifier is very stout. This was probably not the best day for me to get out here and do this, since we have rain and storms supposed to be moving in. But now, as far as getting this radio apart, the GE service information says that you can remove this wiring board here. They call it a sub chassis, but they say that most components can be serviced without doing that, and they advise just to clip off the lead of the original component, leaving enough to attach the new component to, and just J-hook it. Now that's fine and good for 60 some odd years ago, but there's a good chance there's probably bad solder connections under here, especially on these hot tube sockets. And to clean up this mess, I would really need to get this board out of here. Now the IF transformers originally were not soldered into place, but I can tell where somebody soldered these in, so in order to lift this board out, we'll have to unsolder the IF transformers, and that's probably going to entail heating up each connection and then carefully opening up the crimp type connectors, and then we can pull the circuit board or whatever you call it out of here, because these IF transformers, I do believe, are going to require some attention. I've removed one of the IF transformers, and I'm inclined to think these were replaced a long time ago because the soldering looks a lot older than what this later stuff is. Now, the way GE originally designed this was you were to unscrew the IF transformer and it was supposed to just unplug, but these compression fit terminals here have a tendency to get oxidized and make loose contact, so it's really necessary that they be soldered, so I'm not faulting whoever did that. Now, I've taken this IF transformer apart, and this was an exact replacement for the GE. It says GE replacement, and then it gives the part number, and the Miller part number is C12-C11, and I've taken the IF transformer apart, and I did mark it to where I could put it back together the way it came out, and these look to be built like the automatic brand IF transformers that give so much trouble. Now, even though I tuned on this a little bit, I can tell that it looks like somebody else has probably already been tuning on this at some point, because it looks like the core is almost to the end of its travel on here. So now generally what happens to these is they develop silver mica disease, and that's when silver deposits migrate from primary to secondary, and that's what causes your static, because it's causing leakage from primary to secondary, and the static, I believe, is caused by the voltage potential blowing the little particles off. But there are probably 1 trillion little particles traveling across there, so it's a never-ending thing. Also, what happens, these capacitors become lossy, they drift, they change value, and it makes it impossible to bring the IF into proper alignment. So we're going to have to take this apart, disable the internal capacitors, and then put some figure out what value replacement capacitors we need, and then we'll put the replacements on the underside of the chassis once we get everything put back together. Now this second one looks to be just a universal replacement type. It doesn't have the mounting clip like the GE one, the first one that had the GE part number had on it. So I did mark this one on the can itself, on the plastic body, and on the chassis, so we can orient everything back in the way it came out. And like the other one, the bottom slug on this one has been cranked all the way to the top too. Now, I did turn on these slightly, but I didn't turn on them that much. Now, to get these apart, you have to carefully drill out, melt out, grind out, whatever, that rivet. And you got to be very careful, because if you're not careful, the whole thing will fall apart and be destroyed. So what you have is that rivet that holds this whole thing together, and this sandwich, if you will, comprises of this metal pressure retainer thing under the rivet, a top plastic piece, and then you have your 4 contacts, 2 for each winding, and then between those 2 contacts, or those 4 contacts I should say, we'll demonstrate more once we get it apart. You have a mica wafer with silver deposits on it, and then under that you have the plastic bottom piece. Now when you drill that out, this whole transformer could fall apart if you're not careful. That's why when I've done this before, I usually put a dab of super glue on there once I get everything out, and then that way that will prevent the everything from moving and falling apart on us. Now I said these plugged in originally. They may not have, because one terminal you can see is a round hole, and there were things that soldered to that. And I don't know whether that was done later or whether it was that way from the factory. I'll have to try to look at the pictures in the service literature and see if I can determine that. And I also would like to determine if this originally used the automatic style transformers like this one, or did it use those dome top GE style IF transformers. Well, it gets black, and I think the bottom's about to fall out, and I put everything up, and then the sun comes out. But I'm not going to push my luck much today, because it is supposed to storm later. Now, I think before we do the IF transformers, we need to pull this board out and clean up all this mess and resolder anything that needs to be resoldered. But before we do that, I'll talk about IF transformer repair a minute. In most cases, the schematic diagram for your radio is not going to show the internal capacitor values. But even if they show the internal capacitor values, you should not take that as gospel, because there's a good chance, like in this set, that the IF transformers have been replaced at some point in time, and the manufacturer of the replacement IF transformer more than likely used a different capacitor/coil ratio to get the desired results. In other words, the capacitors in the replacement IF transformer are not going to be the same as what came in the set from the factory. And also, even if the IF transformers are original, manufacturers have been known over the course of a model or chassis run to use parts from different vendors. So the schematic you have may be for an early version, but your set may be a late version that uses IF transformers from a different vendor. So there you go, more problems. Now, in our schematic diagram in Beatman's, they show the capacitor values at 75 picofarads a piece for both transformers, which brings up another point. There's a lot of information on the internet, some of it good, some of it misleading. Some of the misleading information is that you can use 100 picofarad capacitors as a universal replacement for any AM IF transformer. Let me tell you, that is bull crap, false. Don't do it, because if you do, you're probably going to not be able to bring your radio into proper alignment, and it's not going to work its best. Generally, the best way to handle this situation is to delete the internal capacitors, put the IF transformer back in the radio, place some variable trimmer capacitors across each winding on your 2 transformers, so that would equal 4 capacitors. Adjust the capacitors for proper alignment, then pull the capacitors out and measure them, and then replace with fixed capacitors of as close to that measured value as you can get. And as far as what kind of fixed capacitors to use, do not use ordinary ceramic disc. Those drift way too much, and you're not going to be happy with the results. The radio will not stay in alignment. You need something that won't drift, such as a silver mica capacitor or an NP0 style disc capacitor. And the NP0 style capacitors will be cheaper. mica capacitors are rather expensive, especially when you're buying close tolerance values capacitors. Now the DC resistance for the factory supplied IFs are 30 ohms for each winding. On our input IF, I'm reading about, for our replacement transformer, I'm reading about 25 ohms for the primary and almost 27 ohms for the secondary. On our output IF, it is just a general purpose thing, it's not a GE replacement, I'm reading about 16 ohms for both windings. So if I went with the 75 or whatever picofarad capacitors that's specified on the factory schematic, we probably wouldn't get the right results here. So here's our board removed. In order to do that, you have to take the strain relief from the power cord off. You have to dismount the IF transformers. You have to loosen the slack in the dial light, and then you flip the board out from the back and flip it over, and you can get to everything on the bottom of it. And you can see this is sort of a primitive printed circuit board. We need to clean all this up while we're in here, and then we need to replace the components, if possible, directly from point A to point B instead of that ugly looking J-hooking. If we have to J-hook anything, then I think we can do it neater than what they did it. And this capacitor wasn't even soldered to this wire here. They tried, but they didn't succeed. And most likely the reason they didn't succeed, several reasons. Number one, they didn't make a good mechanical connection. Number two, they probably weren't using an iron that was hot enough. And number three, they didn't make sure that the surfaces they were soldering to were clean. And oftentimes these old component leads are going to have oxidation on them. It's going to make it difficult to impossible for solder to stick to them. And the way you get a part out is you just heat up the solder cone, and then it will just pull out of the hole. And then to install a new lead, you just repeat the process. And then to reinsert, we first insulate the component lead with heat shrink tubing. Since these modern components are a lot smaller than the originals, and there's going to be more lead exposed that can very easily short out to something. And then we heat the solder cone and then push the component lead down through the hole, and you'll see where it protrudes through the end of the solder cone there. And then we add some solder to the top here, and the capillary action will pull it down into the solder cone where it will make a good connection. And then we cut off the excess lead here that's coming out of the bottom, just like that. And on this 68 ohm cathode bias resistor for the output tube, they didn't even make a good mechanical connection there to the existing component lead. They just tack soldered it on and didn't really do a good job at that. And correction, this is not the cathode bias resistor for the audio output tube. That's the cathode bias resistor for the IF amplifier tube. The audio output tube has a standard 150 ohm resistor, and I ended up replacing it with 180 ohm because that's the closest value I had on hand. There shouldn't be any problems with that. And continuing on, they didn't even tin the power cord before they wrapped it around that connection. It looks like they did use an AC safety cap, but very, very sloppy. Well, the rain's coming, so we got to take a break from this for now. But we did make pretty good progress before it came. Okay, we're back together, and I have the IF transformers reinstalled because I want to see where we stand with this before I go tearing the IF transformers apart. Now, I probably could have shortened this lead coming off the power cord a little bit, as well as this one, but I guess I wasn't thinking, and I'm not tearing all this back apart to do it. So it can just stay like that. And this resistor here by the oscillator coil, that was his original resistor. What is that, a 22K, I believe? The only new 22Ks I had were like little quarter-watt jobs for low voltage use. So I ended up having to solder a piece of wire onto the end of his resistor that he used, and it was fighting me trying to get it down into those two holes. And I didn't want to take a chance of something slipping and me destroying this oscillator coil, so it doesn't look quite as neat as the others do, but it looks better than what they did. Our filter capacitors, I have them mounted on terminal strips, on a terminal strip here on the front of the chassis. Now I've got to get some more full-size terminal strips, so I had to scrape the bottom of the barrel, and I used the terminal strip off of an old junk record changer, what they used for the audio connections. And in this case, this is probably better because this is a smaller terminal strip, and it would come near, it fits in here better than one of my usual big ones that I would have been using. So that looks just fine. Alright, so we have the IF transformers back in place, we have the tubes back in place. I need to solder that copper strap back onto the tube shield of the 12AV6, which we'll do that in a minute. And probably when we're done with these IF transformers, if it's necessary now, the thing might miraculously work normally now that we got all of those bad solder connections taken care of. But since this IF transformer here is really not making good contact with the shield like the first IF transformer does, I'm probably going to have to put a piece of braid on there and solder that to the chassis if I can. So our transformer shield will be making contact with the chassis if that's something I can solder to. That may be aluminum. I really haven't examined it that much to know, but we'll do what we can anyway. Now, one other issue, there was a little translucent red plastic pointer that must have slid over this gold colored pointer. I thought it was all one permanent assembly, but I guess not. And I guess the red thing must have fallen off somewhere. Well, I retraced my steps out there where I was working on this, and I can't find it anywhere. But that's the way it goes. When something falls and hits the ground, or hits the floor, or hits wherever you happen to be working, there's a black hole that's going to swallow it up. Now, pieces of wire insulation, old dud capacitors that might have rolled off the table, in other words, garbage, stuff that you have absolutely no use for, that will eventually get swept up and thrown away, you'll find that stuff, no problem. But if something like a screw or a washer or something important falls and hits the floor, hits the ground, you can forget it. It's gone forever. So we may or may not find that little red plastic translucent thingy that slid over this gold colored pointer. Alright, we're kind of back together. Let's see if it goes or blows. Well, that's a good sign so far. And it really don't look too bad without that red piece, just in case I can't find it. Alright, I'm hearing a little noise. Okay, so performance-wise, it's
good teammate. Life easier.
It's back to where it was to start with, so you know we're going to have to get those IF transformers out and redo them.
Bulldogs, stake at duty.
You can tell how wide this is.
by the taste of victory, a legacy of championships. Strong traditions start with leadership, like Ford F-Series. 48 years straight. Drive F-150.
Audio circuit's fine, but the
Based on 1977
front end's not in too good a shape. So what we need to do now is get some trimmers and take those IF transformers back out, disable the internal capacitors, put the IF transformers back in, attach the trimmers across the IF transformers, and since those cores have already been tweaked on, we're going to have to, probably what we'll have to do is set the trimmers to like a predetermined value. We'll start at like 110 picofarads each, and then we'll see if we can adjust the cores to bring the set into proper alignment, and if we cannot, then we'll just have to adjust the values of the trimmers in small increments until we get them set to a point where we can use the cores to bring it in proper alignment. Now, had this not been tweaked on, we could have just put the trimmers in, set them for proper alignment, taken them out and measured them, and that would have been that. Like I said, yes, I did turn those cores a little bit, but they were not bottomed out like the ones in this transformer are, and I did not turn them that far, and then I moved them back to the approximate position where they were. So we still got some more work to do to this. Yeah, that tuning is pretty broad there.
From Trustmark Park in Pearl, Mississippi, where Mississippi State and Ole Miss are getting set to clash.
Okay, I've drawn a simplified schematic of the way this crap was all installed, this Bluetooth crap, and I'll try to explain it to you and tell you why the way they had it done was probably not the best idea. So we have our incoming 120 volts AC, and back then radios did not have a polarized line cord on them. That wasn't a thing, and most of the time the power switch was in the B- side of the line, and the reason they did that was because in most cases the power switch was mounted to the back of the volume control, and the idea was if they put the switch in the B- side of the line, and if you plug the radio in and hear excessive hum due to noise pickup from the power line, the hot side of the line being so close to the audio circuitry, then you can reverse the power plug and have the neutral side of the line physically closest to the volume control. And we'll expand on that some more later, but for right now, let's talk about the way this was done. So we have our incoming AC coming into the set. We come off here, we go off of the unswitched side of the line, and we go through the heater string, and we go to the plate of our rectifier tube. That's to power the radio and to illuminate the tube heaters. And also we go off into the AC input of our 5-volt switching power supply, and then of course the other terminal, input terminal on that power supply, connects to B- here. So, and then coming out of the power supply we have our 5 volts. It's feeding the Bluetooth circuitry. So when the power switch of the radio is turned on, this power supply and this Bluetooth circuit is active no matter what position the source selector switch is in. So in other words, if we're in radio mode, this power supply and this Bluetooth crap is emitting interference that could be detrimental to AM broadcast reception, as we demonstrated earlier in the video with our little transistor radio that was even picking up the although there was so much noise you really couldn't understand it, but it was even picking up the Bluetooth receiver's welcome announcement. So if this radio was in healthy shape from an RF standpoint, I'm afraid that the broadcast band would just be obliterated with noise and crap. Okay, so coming out of the Bluetooth circuit, we have our audio output and audio ground, which they had connected to B-, and then our audio output goes to one of the end terminals of the single pole double throw switch, and then the output of our radio's detector circuit goes to the other end terminal of said switch, and when the switch is in this position, it feeds the output of the detector to our volume control as normal for radio reception. But like I said, all this Bluetooth crap and switching power supply business is active in causing interference to the AM broadcast band. When the selector switch is flipped down to this position, it disconnects the output of the detector from the volume control and places the output of our Bluetooth device to the input of our volume control. And then of course that goes to the output of the volume control goes to the control grid of the first audio amplifier tube, and we hear whatever content is being transmitted to the Bluetooth receiver via the radio's speaker. Now, them having this audio ground from the Bluetooth module connected to B- is not really a good idea. I saw a video on YouTube where someone suggested, and I've seen this many times in the past, and I've done it a couple of times myself, but I've gotten away from doing it, moving the power switch from the B- side of the line and moving it over here to the other leg of the AC line and installing a polarized power cord where the hot side of the line is switched and the B- or neutral side wide blade no longer has a switch. That's just a straight connection now. Still not a good idea. There's always going to be problems in most things you do in life, and this is one of them. The reason being is a lot of AC outlets are not wired correctly. So you plug your newly rewired set into an outlet that's not wired correctly, and you've got a hot chassis. And you may be asking yourself, why do you have to move the switch from the B- side of the line up here to the hot side? Well, if you were just to add a polarized cord on here with the switch in the B- side, and assuming your outlet is wired correctly, your chassis would be cold as long as the set is turned on. But when the set is off, you have a hot chassis because there is a path from the tube's heater string going to B- there. And they taught us in electronics that you get maximum voltage across an open circuit. So, assuming your outlet is wired correctly, and when the switch is placed in the hot side of the line, then there is no path anywhere past the switch. When the switch is open, that breaks the path. But that presents another problem. You remember that noise I talked about earlier, where they talked about in the old days, if you hear noise, reverse the plug in the outlet? Well, if you happen to hear noise in your radio, because now the hot side of the AC line is running through the power switch, which is on the very back of the volume control in most cases, then you no longer have the option of reversing the plug to get rid of the noise. And like I said, I've done that modification a couple of times, but whenever I did it one time and there was performance issues, I decided not to do that anymore. And I know the safety freaks will be lambasting me in the comments section right about now, but the best way to treat this kind of electronic stuff like this, no matter how well it's been safety modded, is to use common sense and treat all of it like it could knock the crap out of you. And it's for this reason that adding Bluetooth to a receiver that does not contain a power transformer is not a good idea. But if you must do it, I'm going to draw out another schematic to show you a possible better option for doing it. So, have everything just like before in the first schematic until we get to the output of the Bluetooth module, and then you can install a 1-to-1 isolation transformer for audio use, and those are all over eBay. You can get them pretty cheap. Have the output of your Bluetooth module, audio line here, audio ground here, have that connected to the primary winding of your isolation transformer, and then have the output, the secondary winding of your isolation transformer going to your source selector switch, and then the other end of said winding going to B-, and that will isolate your Bluetooth module from the chassis. Now, getting back to Mr. Carlson's video, and we're going to address another problem here with this, and I will briefly explain how he solved that problem. Oh, and just to insert something here, another way you could do this is to tie, or let me back up, another way you could possibly do this, we're going to do some experimentation with this later, is to tie the audio ground from the Bluetooth module to your DC input ground, tie all that together, and then connect that to B-, and of course make sure all your module and stuff is inside the set where it can't be touched, and that should eliminate any hum. Now, on that note, I've got one of these little cheap stereo phonograph amplifiers that you could buy from Lafayette, Radio Shack, various places in the mid to late 60s. Has a couple of 35 C5s, one for each channel, a 12AX7, and a 35W4 rectifier. And then the signal input ground is connected to the chassis, and then there's a capacitor between the chassis and B-, like a 0.047 or something like that. If you connect a record changer to it, it works fine, but if you connect something to it like an AC powered CD player or tuner or cassette deck or whatever, the hum is so bad that it's unusable, and it does not matter which polarity you have the power plug inserted. The only way I found to get rid of the hum was to jump out the chassis isolation capacitor. But of course, if you do that, you have a full-blown hot chassis on your hands, and then you have to plug the amplifier into a line isolation transformer. Now, the reason it doesn't hum with a record changer plugged into it is because, generally speaking, the base of the record changer is not connected in any way through a capacitor and or a resistor, no way like that to the AC line. There's nothing on the base of the changer going to the AC line. The AC comes in through the switch and goes straight to the motor, and then the only thing that's connected to the changer base is the audio ground. So that seems to work out okay, but with a tuner or a CD player or whatever, even though you generally have a power transformer, there is still often a small capacitor connected between one side of the AC line and the metal case / signal ground of the unit, so you have some coupling there. But like I said, we're not doing the Bluetooth thing in this video. We're going to do that later and see what we can make this thing do. Yeah, before we get back to Mr. Carlson and the Bluetooth thing, I go into rant mode about why it's getting so. I just despise auctions, because you think you can get something cheap and then invariably some moneybags is going to run it up. Case in point, this Westinghouse record player on the Goodwill auction site, it's been listed for 2 or 3 times at like $9.99 with no bids, and the last time I thought about putting in a bid on it, but frankly I forgot about it, which should probably be a sign that I don't need it anyway. Heck, I got more than enough plain Jane one-tube wonder record players, and this one here, you can tell it's been in some moisture. The latches and the handle is kind of rusty looking, and of course the inside, nothing special, just your typical 1960s BSR record changer. And the amplifier, I know, is a one-tube wonder plus rectifier, which means this uses a 3-volt crystal cartridge. It's probably dead now. So I figured, well, maybe if I can get it for $9.95, I'll go for it. Well, of course, this time when I make up my mind that I'm going to bid on the thing, somebody else bids on it, and I'm like, well, okay, maybe they just bid the minimum bid on it, and I can get it for not much more than that. Well, no, of course not. I just came in here to look at it, got 6 minutes to go, 3 bids, it's up to $47 plus shipping. And according to the bid history, there's only actually 2 bidders. It's not 3 people, so this is just a case of somebody looking at it, and I see this happen so often at all kind of auctions. They'll see an item that they might not otherwise even bid on, but they see somebody else bid on it, and it's like, ooh, somebody bid on it, it must be valuable, I've got to outbid them, I can't let them get it, I've got to outbid them. And then the other person, after they outbid them, they come in and bid a higher amount, and then the other person, the game player, jumps in and bids a higher amount, and that's the reason stuff like this ends up $47 plus shipping. So we're not going to bother with this. I would a whole lot rather, if you got something you want to sell, you tell me what you want for it. If I think it's reasonable, I'll buy it. If I don't, I'll leave it with you. But when I have to bid on an auction, when I do buy something at auction, on an online auction, I will not bid early just because of crap just such as this right here. If it's eBay, I'll enter the bid into a snipe program and let it do the work. If it's Goodwill or like one of these online estate sale auctions, I'll be sitting at the computer, and when it gets down to a few seconds, I'll put in a bid, and that way the game players don't have time to react to it. Now, I know a lot of people hate snipe bidding. I get it, because during my early days of eBay, I would bid on stuff. I'd be sitting at the computer 5 minutes from the end of the auction just to see how it was going. We'd get down to under a minute. I'd be all excited. Oh good, I got this. This is down to 30 seconds and nobody's outbid me. I've got this. And then it gets down to like 5 seconds and boom. And then I'd usually say a few words that are not very nice. But I've since quit doing that, because in the grand scheme of things, it's all just stuff anyway, and it's not like that was the only one ever made, and more than likely another one will come along. But as far as this Westinghouse record player, I know this is not a particularly uncommon model, and one will probably come along in better shape than this one. And another thing that I wonder about, like this one went 2 rounds with no bids, it just makes me wonder if these people at Goodwill hadn't got people there on staff running the prices up on this stuff. And of course I have no way of proving that, but I know it happens on eBay, so I'd be stupid to think that it doesn't happen on here. So, but as far as the snipe bidding, I understand why people don't like it. I also understand why people do it, and after I lost out a few times on stuff at the last second from bidding early, then I started doing it. No, it's no guarantee that you're going to win, but it definitely increases your chances, and also increases the chances of you actually getting the item for a somewhat reasonable price, because a lot of people get way too carried away with these auctions. Let's hit the refresh button and see where we are. This thing ought to be about over with now. Did somebody snipe it up? 53 seconds to go. Let's sit here and watch it and see if somebody snipes it up in the last 5 seconds. Unfortunately, Goodwill, the snipe programs don't work with Goodwill, so you have to actually manually sit there and do it on the Goodwill auction sites. eBay, I can just enter in a bid days before in the snipe program and forget about it. Well, still 3 bids, 16 seconds. But I'm getting I'm even tired of fooling with eBay. 8 seconds, because the shipping has gotten so darn high on everything, and people on there think their stuff's gold. 1 second. Somehow I don't think I've got enough time to put in a counter bid. Okay, so it didn't get any more bids. Now the interesting thing is, there's a strong possibility this thing might get relisted, because there's a good chance that whoever run this bid up is going to go, oh crap, what have I done? Or if this was an inside job, then this will be relisted in a few days. Oh, and regarding the auction crap, another thing that pisses me off about this kind of activity on online auctions is people see this, and I'm not necessarily talking about double digits, I'm talking about when they really get carried away on stuff. People will either see where somebody bid $500 for something that should have been $50, or they'll see somebody asking $500 for something on eBay, and then you try to buy theirs for a reasonable price, and they have a conniption fit. Oh no, I've researched this, and these go for X amount on eBay, and I've just gotten so when they pull that crap, I tell them good. If it sells for that much on eBay, then that's where you need to sell it. See, the problem is people want the eBay bucks, but they're not willing to take the risk or go to the trouble to get it. And what I can't convince people of is you can ask whatever you want to for something. You can ask $1 million for something if you want to. That don't necessarily mean anybody's going to give it to you. And I can point out a bunch of things that's been listed on eBay for some of it for years at the same ludicrous price, and they just keep relisting it and relisting it and relisting it, and nobody's buying it. And then another thing, even if something sells for an exorbitant amount on eBay, that doesn't mean it's going to sell for a big amount the next time. And it also doesn't mean that you're going to get that for it at your flea market, thrift store, estate sale, or yard sale. eBay has a worldwide audience. Your yard sale does not. And most people going to yard sales are looking for a deal. And I've told 1 or 2 people if I wanted to pay a huge eBay price for something, I'd sit on my butt at home and just not leave the house. And apparently a lot of people have that problem, those that are getting on there paying $200 and $300 for little black plastic crap 13-inch TVs, when there's still way more of those things out there than there are people who want them. If you do a little looking locally, I can guarantee you could find one for $5 or $10, or maybe even free. Now, case in point of stuff going for an exorbitant price on eBay not being the norm, a friend of mine was telling me the story about this guy he knew saw that I believe he saw that a relatively common 50s RCA radio went for a big price on eBay, so he got it in his head that, you know, he was going to start picking up those radios and restoring them and making big bucks off of them. And my friend tried to tell him, look, what you witnessed is the exception, not the rule. That was just two people getting carried away, and that's probably not going to happen again. Well, the guy didn't listen to him, and he ended up buying one of those RCA radios and spending more money on it than he should have. And then he thought he was going to make hundreds of dollars off of it, and he couldn't even get his investment back out of it. And then a while back, well, it's probably been about a year ago now, me and a fella that I used to associate with, the one that I told you several videos back that we had the falling out over politics, we were at a little hole-in-the-wall flea market, and this guy showed up, and I feel like all he wanted was some alcohol bucks, but he wanted to sell some old 70s all-in-one 8-track record player, AM/FM stereo, and the flea market lady pointed to me and told him, well, there's your man right there. And I looked at it, and he's like, it works great. And I'm thinking to myself, sure it does. The thing was covered in nicotine and filth, and it was probably something he dug out of the trash somewhere. I offered him $10 or $15 for it, I don't remember, and that was probably $10 or $15 more than it was worth. No, I'll just take it back with me. These things go for more than that. And when he left, the lady at the flea market, she said, well, you offered him $10, you offered him, we'll just say $10 I offered him. She said, you offered him $10 more than I would have for it, because I know that I would have lost my $10, and you're about the only one around here that comes around here that would have wanted it. So, and I know you're not going to pay a lot for something like that. And I said, no, I'm not, because it's old, it's dirty, it's going to need work, and I'm just not going to put a bunch of money in it and then get stuck with it. So it didn't hurt my feelings one bit that he drove off with his ratty looking all-in-one stereo still sitting on the back seat of his ratty looking vehicle. But anyway, getting back to Mr. Carlson's video where he added Bluetooth to a high-end Stromberg Carlson set that he had restored, and I believe this radio had, if I'm not mistaken, a pair of 6L6s and like a 12 or a 15-inch electrodynamic speaker. In other words, it had a high-performance audio system, so something like that would be more worthy of adding Bluetooth to, rather than adding it to some little dinky All-American 5 radio with a 4-inch speaker in it. But anyway, this is the way he powered his Bluetooth modification. He used the 6.3 volt tube heater winding off of the power transformer, so no switching power supply here to worry about. He was able to place a momentary switch in the tuning system on the radio, and whenever you tune the radio to the very end of the dial, it closed this switch, which fed 6.3 volts to a simple half-wave rectifier and filter capacitor network. And of course he did put a bleeder resistor there for the filter capacitor and a surge current limiting resistor for the diode, and I believe he used a Schottky diode. And then that rectified and filtered voltage feeds a 5-volt regulator, which in turn supplies 5 volts to the control circuit and the Bluetooth module that he added. Now in his set, it was easy for him to add this switch into the tuning mechanism. Now I understand each radio is different, and on some sets you may not have the luxury of being able to easily add a changeover switch in the tuning system. You may have to add a manual switch somewhere on the back of the radio in a hidden spot. But anyway, Once this power is engaged, well, I'll now draw a schematic, a simplified schematic showing you what happens next. Okay, so you have your 5 volts going to the Bluetooth module, and you have your 5 volts going to this control board that he made, which consists of a double pole, double throw relay, as best I can figure, and of course the relay driver circuitry, and I believe he also incorporated some type of time delay circuitry to keep the Bluetooth from, to keep the audio in the radio from being switched over until the Bluetooth had a chance to go through all of its preliminary boot up stuff to prevent any kind of noises or pops, but anything like that. But for the sake of simplicity, I'll show you what it appears that he's doing here. So you have your double pole, double throw relay contacts, and when the Bluetooth switch here on the radio is not engaged and you're set for regular radio reception, you have the contacts on one side of the relay that connect the detector output into the volume control, and then you have the contacts on the other side of the relay connecting the cathode of the final IF output tube to its respective circuitry, whether it be to ground or through a resistor or whatever the case might be in your radio. Well, then whenever this Bluetooth switch is activated and turns on all this, it switches the relay contacts down here to Bluetooth mode, so we're now feeding Bluetooth audio through the radio's audio amplifier, and then it also opens up the cathode of the final IF amplifier tube, preventing any kind of noise or maybe any leak through from a powerful radio station from getting into the audio circuitry, which can happen even if you break the path from the detector tube to the volume control. If your front end stages are still active, then you could still have some possible leak through. Now, earlier in the video I misspoke and said that he disconnected the B+ from the front end stages of the radio. I was incorrect about that, which I saw after rewatching his video. What he actually did was broke the cathode connection, which is low voltage from the circuit, killing the final IF stage of the radio, which prevents any kind of noise or station audio to leak through to the audio stages of the radio. But no matter what kind of radio that you're going to put a Bluetooth thing in, whether it be a series string set or a set with a power transformer, you really need to come up with some kind of way to kill power to the Bluetooth circuit when you're in radio mode. And if you're using a set that has a power transformer, then you need to try to forget about the switching power supply and just go with something like this. Just rectify your voltage off of the 6.3 volt heater winding, filter it, run it through a 5 volt regulator, and there you go. Now, in the case of a series string set, you might have to use a switching power supply, or if there's enough room, you could install a small step down transformer and then rectify it, filter it, regulate it just like what he did. And then, like I said previously, on a hot chassis set, you would be better off using this audio isolation transformer on the end of your coming out of your Bluetooth module to isolate the output of the Bluetooth module from the power line. But really, the best and easiest way to do it is just to get a little low power transmitter, such as this little dude right here that we did a video on some time back. It's not that far back, so you should be able to find it. This was a little $30 thing that I ordered from out of China, Of course, that was just before the tariffs and all of that took place. So, and the post office stopping shipments from China to the United States. I don't know what the status is of that now, or what the status of these little transmitters are as far as getting one from there, but for a $30 transmitter, this doesn't do half bad. My only complaint is the range is terrible. You basically have to have it right up next to the radio in order to get anything. So what you could do is you could buy a Bluetooth receiver that has a headphone output, or an MP3 player, or CD player, or a cassette player, or whatever audio device you choose that has a headphone output. Plug this transmitter into the headphone jack, tune everything up, sit this by your radio, and you can transmit whatever you want to the radio without having to make any modifications to the radio whatsoever. Now, some more pointers as far as adding Bluetooth to a radio. You don't need to have all the slopification like this guy did with the GE. Your audio cables need to be shielded. They need to be kept as short as possible, and you need to run any audio cabling away from, as far away from any lines, especially those carrying AC. You need to have them as far away from those as possible. And you need to keep all of your incoming power leads as short as possible. Preferably wrap them up in a twisted pair and have them as close to the chassis as possible and as far away from any, like I said, any audio leads as possible. And as far as mounting the Bluetooth module, you probably do not want to mount it under the chassis, because the chassis is going to act like a shield, and that's going to hinder reception. You know, you need to mount the module preferably to a place on the chassis where it's not visible from the back of the radio or whatever, but you know, you can mount it to the front of the chassis, the top of the chassis, or whatever. If you have to mount it on the rear apron of the chassis, you can do that, but you know, it would be visible if somebody were to look back there. But you don't want it enclosed in the chassis, because like I said, that acts like a shield that's going to hinder reception. Now, something else we need to talk about, and I promise we're going to get to the IF transformer repair momentarily, but something else we need to talk about concerns all this slopification and liability. As you know, we live in a sue-happy world. People will sue for anything these days. And let's say you do a very sloppy job of overhauling a radio, and then you either sell it to somebody or it's one you fixed for somebody, and in either case you charge them an arm and a leg for it. Now, I didn't pay an arm and a leg for this GE, but at any rate, you charge them an arm and a leg for it and make them think it's professionally restored and blah blah blah, and then they get it home and they either get the crap knocked out of them, or worse, somebody gets electrocuted, or the radio catches on fire and causes property damage. Then there's a good chance that they're going to come back and sue your pants off. Like I said, we live in a sue-happy world today, and it doesn't take much for some people to go run to a personal injury lawyer. And you know, some of it I think is justified, and some of it I think are just get-rich-quick schemes. So you need to be neat with your work. You need to make sure you need to minimize the chances of anything going wrong that could result in fire or electrical shock. I remember back whenever I was about probably 17 or 18 years old, some guy found out about me, and he brought this rather ratty looking mid-30s Crosley Tombstone radio to me to repair, and he proceeded to tell me that, well, it plays, but it has this loud background hum, and I want to know what it's going to cost to get rid of the hum. And I said, well, it needs new filter capacitors. But I said, given the age of the radio, it really needs to be gone through. And he said, well, how much is it going to cost to do all that? And I gave him... But anyway, the battery just abruptly died on me. But anyway, the guy wanted to know about what it would cost just to go through the thing. And I don't remember what I told him, but I gave him a general ballpark figure. And I said, you know, once I get in there, it may be a little cheaper, it may be a little higher. Oh, heavens no, that's highway robbery. I'm not paying that. How much you going to charge me just to replace those, what'd you call them, the filter capacitors? And oh yeah, you might want to put me a new line cord on here. You know, this one looks kind of bad. And I don't remember. I think I told him 20 or 25 bucks to put a couple of filter capacitors in it and a line cord. And well, that still sounds high to me, but I'm gonna let you go ahead and do it. So I replaced the filter capacitors, put a line cord on it. And I think I might have replaced the grid coupling cap on the output tube and sent it on its way, and I never heard anything out of him. If that were to happen today, we wouldn't do that. You know, we would either do it correctly or he would be leaving with his item, because I'm just not going to open that can of worms. But anyway, you know, that's why you really need to be neat in today's world. And another thing, this is an example of one of those switching power supplies like what was used in that radio. You can get these for $10 a dozen. Yeah, I'm exaggerating a little bit, but not by much. And basically all he did was just cut one of these up and hardwire the 120 volts on the input here, and then ran a cable from the 5-volt output to the USB module. It stands to reason, given how cheap these things are, they're being blown out by the billions from China Incorporated. They're not going to have any type of RFI suppression to amount to anything. They're going to be made using the cheapest possible components, and safety is really not a major concern with these. You know, something you pay $2 for, I wouldn't put a lot of faith in. And I have known these cheap little power supplies and switching wall warts to, number one, either just overheat and burst into flames and catch somebody's house on fire. And another failure mode is when the regulator circuit fails, like in the feedback loop in the switching power supply. It causes the output voltage to go way, way, way up, sometimes in the hundreds of volts, which can cause whatever's plugged into it to explode. So you don't need one of these cooped up inside of a radio and have it decide to go up in flames. So that's why it's probably not a good idea to use one of these. I mean, I use these because I have to charge batteries and certain things, but I do not leave them plugged in unattended. I always make sure I'm here and close by in case something does happen with one, that I can yank it real quick before something catastrophic happens. Now, something else Mr. Carlson did to his Bluetooth conversion that I don't think the guy with the GE did is Mr. Carlson connected coupling capacitors between the output of his Bluetooth module and the volume control, and that's just to isolate the Bluetooth module from any DC that might happen to be present, or to isolate the input of the radio from any DC that might be coming off of the Bluetooth module. So that's just a little safety precaution. And he tied the left and right output together, and I believe he added appropriate load resistors there. I think the Bluetooth module and the GE, I think he just ran one channel of it out, which of course if you're playing stereo content through it that way, then all you're going to hear is the channel that's connected, whereas if you have the left and right tied together, then you're going to hear the both channels in mono. So I think I'm about done rambling about Bluetooth modules and safety concerns and auctions and that sort of thing. So I think we could now get ready for the IF transformer repair in the radio, and if I think of something else, I'll insert it later. Oh wait, we can't get to the IF transformers yet. We have to take a more in-depth look at this blob USB mess that they had in here. So this white thing is the cannibalized USB power supply, and it looks like they took the circuit board out of it and flipped it around, so they had the 120 volts coming in through this shielded cable, which is silicone to the front of the thing here, and then they ran that through the hole where the USB 5 volts would have normally come out, and we have these little strandies sticking out here. So yeah, what could possibly go wrong? Yeah, think back to what I just said a few minutes ago about liability, and then the front here where the prongs would have come out to plug into the AC outlet, that was cut off, and like I said, they reversed the board, and they had the 5 volts coming out of here going into the Bluetooth module, and this looks, as best I can tell, just like the one that Mr. Carlson used in his modification. And then it would appear that the output of the Bluetooth module is going through this other board, which I'm guessing is an audio amplifier. It has left and right outputs on it, but they only have one channel. They only had one channel connected. So yeah, very, very sketchy. Now, this Bluetooth module has holes in it to where you can use standoffs to actually mount it to a chassis with bolts like what Mr. Carlson did. So I tell you what, let's get some pliers and cut all this crap loose and see if I can determine what's what here. They just simply had the Bluetooth module siliconed on the front of this thing here. I pulled it loose. Okay, here's the little power supply guts. They had the AC running through this shielded audio cable using the red and white conductors, and the shield they just left dangling there. Still not a good idea, because if they weren't careful, this could have touched one of these conductors and that could have caused problems, because I think they had this other end wrapped around that lug on the volume control that wasn't soldered. And then they soldered this red and black wire. That's our 5 volts output. Now there's not much to this. A little switching transformer, some caps, and on the bottom we have our bridge rectifier, our driver IC, and some more supporting components, but not much to this at all. Well, my suspicions were correct. This is an audio amplifier. It's a Class D 3 watt per channel stereo audio amplifier, and it looks like they were only using one channel of it. Now there are versions of this that have a volume control built onto it, but this one here obviously does not. You have to supply your own volume control on the line input side. Now this is meant to drive like an 8-ohm speaker or whatever, so I don't know why they felt the need to put this between the output of the Bluetooth module and the volume control input of the radio. I wouldn't think that would sound very good unless they were trying to compensate for a deficiency of the radio or what. I don't know what the deal was. I know the one Mr. Carlson modified with this exact same Bluetooth module that I have in my hand, he did not add any kind of amplification between the output of the module and the input to the radio's amplifier. I mean, this Bluetooth module should output a line level signal, and there would be no need for any other further amplification unless maybe you were running it through a one-tube Wonder record player amplifier or something. Oh, and by the way, these little modules, these little audio modules, they're about $1 a piece, something like that. And these little Bluetooth boards are Not too expensive either, I don't think. This one has a, looks like a mini USB connector on it, and looks like a stereo headphone jack. I'll have to go look this up and try to see what all that's for. Like I said, I'm really not up on Bluetooth stuff. I don't have anything that even transmits a signal. The only thing I've ever had that would receive a signal is that dinky little record player thing that you've seen in other videos of mine that has the USB memory stick jack on it. Now, I'm not going to throw all this stuff away. Maybe if one day I get something that will transmit a USB signal, we might take some junky radio that has little value and add this stuff to it and do a little experimentation and try to come up with a correct, neat, and safe way of doing it. Okay, so it looks like this USB port on here is for plugging in an external power supply. So you have the option of either plugging the USB cable into this and running it off one of those little 5-volt things, or you can go directly via solder terminals right here. And this is a headphone output jack apparently, or you can have your output coming off of these solder terminals, and they indeed only had one channel used, which means if they were receiving a stereo if they were receiving stereo content, then only one channel would be heard. Of course, if they were only receiving mono content, then it would be fine. But we're going to hang on to this stuff. We'll just put it in a little baggie for future use. I might down the road try to come up with a way to add this Bluetooth module to that radio without the use of silicone or liquid tape, and we'll keep the use of zip ties to a minimum too. But the way they had it done was just downright dangerous and sloppy, and probably didn't sound all that great. So enough about the Bluetooth. I think I've covered all we need to know about that. So we'll move on to the IF transformers now. Well, I plugged the thing into a USB supply and our blue light is blinking, so apparently the module is doing something. I have the first IF transformer removed, and we're going to use the variable speed drill very slowly to get this rivet out, and at the same time I'll be holding it together between my fingers to help prevent it from falling apart. But do this very slowly. You don't want to go at this full throttle, because if you do, you're probably going to end up destroying something. Alright, we have the rivet drilled out, so the key here is slow and easy. Alright, rivet carefully removed, along with the metal clamp compression thingy and that plastic piece, which we're going to need when we get ready to put it all back together. Now that's the silver mica capacitors. You have a contact on the bottom and a contact on the top for each winding, and then our mica wafer has the silver deposits on it. Alright, I've got the tabs cut off and sort of bent back over. Hopefully I didn't break the fine wires that go to the coils that solder to these tabs, because these things move very freely. That's why you kind of have to apply some resistance to them to try to keep them from moving as much as possible. And I'm doing something a little bit different than the way some people do it, and we'll see how it works out. I have the plastic top piece positioned back down and holding it together with pliers, and I melted the plastic to sort of fuse it together. And then I'll give this a few minutes, and then we'll go to the other side and do the same thing. Alright, the plastic is fused back together. The connection pins don't wiggle. I just did an ohm meter check. Thank goodness we didn't break anything. Now it would be better if I had like some super glue or 5-minute epoxy or something I could reinforce this where I melted this together, but I don't, so we're not going to worry about it. I'm just going to put it back together and hope for the best. Yeah, that mica wafer is not as cruddy as some I've seen, but we can see a bit of abnormality here. Okay, IF transformer number 1 is void of its internal capacitors and is installed back in the radio, and we made a final resistance check just to make sure the windings are okay and all is good. So all we have to do now is figure out what value of capacitor to put, or capacitors to put across the primary and secondary. Now let's get the second IF transformer out and do the same thing to it. And the second IF is removed, and remember what I said earlier in the video, before removing the transformer and taking it apart, put a mark on the chassis, put a mark on the can itself, and put a mark on the, and it looks like it's trying to rain, put a mark on the plastic. Well, this one didn't go as well as the first one. Even though I was trying to be careful, the damn drill caught in the plastic and tried to twist it out of my hand, and I broke one of the wires here. So I'm going to have to go put this under magnification, but I hope I can fix that. But looking at the mica wafer out of this one, it's in worse shape than number 1 was, so this one was probably the biggest culprit of the two. Well, this one you can forget because it broke up here at the coils, and I'm not dealing with it, so go to plan B. Okay, here's where we are at this point. I found a PC board mounted output IF transformer out of a mid-60s piece of junk RCA radio that had been basically cannibalized. I have no idea what the condition of this is in. This is one of those where one winding measures about 25 ohms and the other one measures about 13. The pins were not long enough to completely protrude through the connections here on the receptacles, so I had to run some solder down in there. On our first IF transformer, just as an experiment, I had some 100 picofarad capacitors on hand, so let's see what happens when we go with the internet specified universal value. It might work, it might not. Alright, so here we go. And just turn it wide open. Wait on the tubes to warm up. Well, that don't sound too good. All I'm getting is a light hum in the speaker, no interference, and not a darn thing in the way of a radio station. So we've gone from bad to worse here. Well, I've determined that the local oscillator in the GE is working by placing our Zenith pocket transistor radio up next to the oscillator coil and tuned to about 850 or so. It's not really critical. And then we just tuned through the dial on the GE, and I could hear reactions in the transistor radio, so we know our oscillator is working. Now I think the next step is we're going to require the services of the signal generator and see if we can blow any kind of signal through this at all. I'm betting not, and then we might even have to employ the services of the signal tracer to see where we're losing the signal. Like I said, this second IF, all I know about it is the windings have continuity. I don't know anything about the internal capacitors in it, or as far as the compatibility with this radio, but both of them are just basic All-American 5 radios, so you would think this one would work just fine in here. It could be the fact that we have 100 picofarad capacitors across here, and that may be so far out of line that we may not be able to bring it into alignment. If that's the case, then good. Then we'll have proven that 100 picofarad is not the be-all end-all universal value for AM/IF transformers. Okay, here's what we're going to do. We have the signal generator warmed up. I'm going to inject a signal into the grid pin 1 of the first IF amplifier tube. That will tell me if that stage is working and if this second IF transformer is passing a signal. And I have the generator turned wide open. So let's see. Yes, it's passing a signal, but probably not as stout as I would like it to be. Alright, I'm going to turn the generator output down a bit. Volume is wide open. Now let's try to tweak these slugs and see if anything happens. Yeah, it's getting a little louder. Okay, let's go down some more. Okay, we're getting softer, so let's go back the other way. Okay, now let's get to the one on the top. And technically I should be using a plastic tool for this, but this is what I have. Okay, why is it sticking? Okay, the top core, I was able to get it better, but I had to turn it all the way as far up as it would go for that to happen. It might could still go further, so that tells us that 100 picofarad is really not an ideal value for this. Now I think we got other problems here besides IF issues. Yes, I did run an audio signal earlier in the video via the signal generator through the volume control, and it seemed to be pretty stout, but that generator doesn't have an adjustment, an attenuation for the audio. So I just touched my finger to the volume control and I'm not getting as loud of a buzz as I should, so I'm checking some things. Our plate voltage on the 12AV6 reads about 61 volts. The schematic calls for 45. I'm just doing some resistance checks to check this couplet out, and I should be reading 470K between the control grid of the output tube and ground, but instead I'm reading, if it'll get on there, well, I may not be reading anything now. That may be wide open. Okay, we're supposed to have a 6.8 meg resistor between the control grid of the first audio tube and ground, and that's wide open too, so it looks like we're going to be rebuilding a couplet. And I think I see now why somebody had that external audio amplifier module between the output of the Bluetooth and the input of the volume control. They were trying to compensate for a fault in the audio circuitry in the radio, and I should have paid better attention to that earlier whenever I was testing. So as much as I really don't want it to happen, this board might have to come back out of here again, and then we'll have to rebuild this couplet with individual components. This is a schematic that somebody sent me on the computer. For some reason I can't rotate this. I don't know why, but this couplet contains 7 components. So coming in off of our volume control, well, let's look at something else here. Okay, so let's start over. Coming off of our second IF, we go down here, and back this way is the AVC line, and then coming back up this way, I'm using a screw as a pointer, we go into the input of the volume control. Also coming up here, we go up through this line, and we go to a 400 picofarad capacitor, and then the other end of that capacitor goes to ground. So that's in that couplet. That's your radio signal's input to the volume control. And then of course the bottom end of the volume control goes to ground. And then we have the wiper of the volume control going through a .002 capacitor. And then the other end of that goes over here to the grid of the first audio tube. And then also connected between the grid and B- we have this 6.8 megohm resistor that seems to be open. And then coming off of the plate of the first audio tube, we go over here to our 220 picofarad capacitor to ground. The purpose of that is to strip off any RF that might be at this point, but we don't want the capacitor to be too big, because if it's too big we'll start shunting audio frequencies to ground, and we don't want that. We just want the high frequency RF to ground. Also coming off our plate, we have our 470 k ohm plate load resistor, which is reading about 560 k, so it's gone up a bit, and it runs down here to our B+ line. And then we also have connected to the plate our plate to grid coupling cap, a .005. It seems to be okay. I'm not getting any DC voltage on the control grid of the output tube, but this 470 k ohm grid leak between pin 7, the control grid of the output tube, and ground seems to be open. So for right now we might can just substitute these resistors out, but to do this correctly we really need to get this couplet out of the circuit completely and just rebuild it with individual components. As far as this 45 volts on the plate of the first audio tube being a bit high, about 61 volts, the schematic says to all voltages are checked with a 20,000 ohms per volt meter, and with me checking it with a high impedance digital meter, that could explain why that voltage is a little high, so I'm not concerned about that. And one thing I also need to do, since we know that the volume control has been replaced, we need to make sure that he used a 500K or a 1 meg. A 1 meg would be better than a 5. Well, we need to make sure he didn't use something lower than a... And I also need to make sure that this replacement volume pod is at least a 500K. I certainly hope he didn't do something dumb, like stick maybe a 10K or a 1K or something like that in there, because that could be detrimental to your audio quality too. I ran into that on a radio once before, where somebody stuck a pod in there that was too low. So let's go check that. Well, they actually put the right size volume control in here, so that's one less thing I've got to worry about. Alright, I'm going to go fetch a couple of resistors, and we're going to substitute for these open ones in this couplet and see what happens next. Alright, excuse me, my meter wasn't making good contact. Our 6.8 meg grid leak resistor for the first audio tube is reading 9.4 meg, so it's gone up, but this grid leak 470k ohm grid leak for the output tube was definitely open, and now that I've tacked it in circuit, we're now reading 463k ohms. So let's put some juice to the radio and see if we have any better volume. Well, that didn't really help our audio much, but I just decided to pull the whole thing out of here because there's other parts that have gone out of tolerance, and then as I was doing it, this lead just broke completely off there at the end. So we're just going to rebuild this with individual parts, and fortunately I was able to get this off by heating it up from the top side, so hopefully I can put the new parts in that way and not have to pull this board back out. Okay, I think we have all of the couplet parts replaced. A slight bit sloppy, but I was able to do it without pulling the board off again. So let's have a rundown of our components. 400 picofarad cap between the high side of the volume control and ground. That's a RF bypass cap. I didn't have a 400, so I just used a 500 picofarad disc. Here's our volume control coupling cap that goes from the center of the volume control to the control grid of the first audio tube. And then we have our 6.8 meg resistor between the control grid of the first audio tube and ground. And then on the plate side of the first audio tube, we have our plate to grid coupling capacitor. And then we have our, where is it, right here, our 470k ohm plate load resistor. And then on the grid side of our coupling capacitor, we have the 470k ohm grid leak resistor there. We have our, did I say 6.8 meg ohm grid resistor for the first audio? If I didn't, I'm saying it now. And then we have our 220 picofarad plate bypass for RF dumping on the plate of the detector tube. So we have 1, 2, 3, 4, 5, 6, 7 components, and that's how many was in the couplet. So everything's accounted for. So we're about ready to connect a speaker to this and see if it works or does nothing or releases the magic smoke. Now believe me, there were a few difficult parts that I wished I could just omit from the design and pull a madman months, but with GE, if they used it, then it was critical for proper operation, because as cost cutting as they are and the way they like to cut corners, if they could have eliminated a part, they would have done it. Well, I'm hearing static in the audio. That's a good sign.
Rigorous and creating personalized treatment plans. Now with we're right next door when you need us. Treating distance to the
Performance still sucks, but at least we're not any worse. I think we're going to dig up another 12 AV6 just to see, because we're running about 60 volts on the plate. And like I said, that might be because we're using a high impedance meter. Well, our volume is louder now, even with this inefficient speaker I'm using. But our cathode voltage on the output tube is a bit low, which means it's probably a little weak. Our plate voltage on the detector and first audio tube is a little high, which could potentially mean it's a bit weak. And then we still need to deal with this IF transformer issue. Alright, we're hooked to the speaker and the radio that's much more efficient.
And use code SECOND3 to get a free second month. Real people pay to do their
And we still got a loose connection in here somewhere. I think it's on the antenna connection, but we'll deal with that later. But changing that audio couplet out. Alright, MOX, we don't need dead air. That's getting so loud now it's distorting, but our IF issue still needs to be dealt with.
We need physical gold and silver. Call 1-800-341-8584 now. That's 800-341-8584. Or visit us at AdvantageGold.com. Performance may vary. You should always consult your financial and tax professional.
Like I said, this I think just proves that
the world's most aggressive collection agency.
Whoever did this put that audio amplifier module in there to compensate for an audio problem in this radio that was caused by that couplet. I can only imagine what that sounded like. I should have. I was looking on eBay last night, and I can get a little MP3 player that will transmit a Bluetooth signal for about $22, $23, something like that.
Stanley from New York.
I should have just went ahead and ordered one of those and left that crap in here just to see what it would sound like.
The IRS for $2,000. Mark in Michigan owed $225,000 after Coast One stepped in. Walked away paying less than $1,500. Call Coast One now. A 10-minute call can save you up to 93%.
Yeah, we got to find out where that bad solder connection is.
3186. Sponsored by Coast.
And we're now trying to get a little DX that this thing wouldn't touch before. Even with the lacking audio circuit, had the IF transformers been on top of things, we should have still gotten some DX.
We're out there in center field. Wilson, you can settle the fans.
Okay, that's the camera. I mean, it's still not where it should be, but it's a far cry from where we started out. Alright, I found some 120s, and I just tacked them in. I hope the lead length is not going to be an issue. This may not be right either, but at least this should tell me if I need to go up or down in value. I should probably just wait until my trimmers get here, but I'm a bit impatient. And I don't have a large assortment of these mica caps on hand because of the cost involved. Mostly what I got here is either stuff I inherited or stuff that I bought for a specific need, and that was that. Well, I upped the capacitors to 120 picofarad, and I think we're going to have to go lower instead of higher. And I just checked the 12AV6, it's okay. The 50C5 is a bit on the tired side. No excessive gas, but emission is not so great, and it looks like it's dropping off. So yeah, that's the reason the cathode voltage was a little low on it. No short. And this is getting to be a pricey tube. I can remember when I first started collecting radios, you could buy 50C5s for a couple of dollars. Now they're about $25. I guess because they're used in virtually every All-American 5 radio made from probably about 1950 until the end, and even in some phonographs too, and they're a high failure tube. So I think the octal-based 50L6s hold up a lot better, but it's not like we can shove an octal tube in here. Okay, doing a little experimenting with capacitors. I took 120 and 100 and put those in series for each winding on the transformer. Now if I'd have put two 100s in series, that would give us 50 picofarads. So 120 and a 50 would be what, 60 or 70, something like that. And I'm now able to bring the alignment closer in than what I have with any other value I've used.
7 o'clock Green Bay time, 6 o'clock Mountain, and it is...
Well, this is quite a switch. We have the signal generator hooked up to the radio, tuned to 455 kilocycles, and the volume turned wide open. And I'm able to blow a weak signal through it with the generator on its lowest range position. Of course, I have the output level for the turned all the way up, but we're on the lowest. Yeah, actually I can hear a little bit of going through with about a quarter of the way up there, but we're on the lowest position on the range switch. So let's adjust these cores and see if we can come up with something. Now, the capacitor calculator told me about 57 picofarads for 120 and 100 in series. That sounds about right. Okay, that's getting weaker. Okay, that's peaked out right there. Now let's go to the trimmer on the other side over here, if I can get to it. Without whatever's loose in here. Okay, now what is that crap? Alright, I'm going to need two hands for this. I'm going to have to hold the chassis up. I hope that's not the second one trying to give us trouble. Okay, we were able to peak it out without bottoming out the cores, so whatever value this is might be satisfactory.
For the rest of the game, because of those held it. Nobody has access to it.
Well, we might have to make some checks. That second one might be trying to crap out.
Answering your questions, giving advice that you may or may
Run with challenge.
Alright, I put those capacitors in more permanent, and I replaced the 50C5 with one that I had that checked like new, so now we have more volume,
running the load that the whole world is running.
and it's not as distorted.
Download the app to take part.
But that static I'm concerned about. It's not going to be the first IF. There's no way it'll ever do that again with those outboard capacitors.
Baseball trademarks used with permission. All right, when it comes to getting life insurance for your family, a lot of...
Now this second IF, I've tried to adjust it, but I don't have a tool handy that will fit that slug. So what I'm going to do, we're going to feed an IF signal into the grid of the IF amplifier tube, and then we're going to vary the frequency of the signal generator and see if it gets worse or better. If it gets better as I vary the frequency, then obviously that transformer will be out of alignment. And now on my audio output tube cathode, I've got almost 7 volts. I had less than 5 before. And 119 on the plate, so that's gone down a little bit. So when you have an output tube that reads higher than specified on the plate and lower than specified on the cathode, then that's a pretty good indication that you've got a weak tube. Alright, let's adjust the signal generator frequency and see if it gets louder. No, it's pretty well right on target. I mean, I would like to get an alignment tool in here and peek this IF transformer out, but this tells us that it's not horribly off, and usually these kind of IF transformers don't get out of alignment unless the capacitors inside of the IF transformer drift. Now the old style IF transformers with the trimmers on top, now those do tend to, I seem to find a lot of those that are off, which a lot of that could be due to somebody twiddling with them. But as far as reliability, those older type of IF transformers were much better. On those, the inductance was fixed and the capacitance was variable, whereas on these newer transformers, the capacitance is fixed and the inductance is variable. So on those older IF transformers, there's no silver mica disease to take place. Occasionally you'll run into one with an open winding, and you'll find ones that the lead wires running up into the transformer the insulation is rotted away on them, and you'll have to take the transformer apart and replace the wiring. But as far as a defect that would necessitate discarding the transformer, that's something that's rarely seen on those old IF transformers. And as far as these miniature types, back in the day, I don't imagine too many radio shops repaired the old ones, because back then you could run down to the parts house and buy a set of IF transformers and just pop them in there and send the radio back home. But in today's world, you can't do that. I really don't know when those IF transformers stopped being made, but I would guess they were probably discontinued by the mid-70s, I would imagine. Okay, that second IF in that radio looks like it's going to be problematic. The slugs are stuck and won't move. I found another tool that would fit, and I could tap on it and it would pop and make static. So I found this old junk GE chassis out of a busted up clock radio that I know the IF transformers were bad in. That's the reason I didn't fix it, because the thing was in such bad cosmetic condition. So this is the output IF. I've already marked everything. We're going to open this up and we're going to try one more time to do this without destroying the thing, and I believe I'm going to drill the rivet out by hand this time, even though it may take longer. Of course, it would help if I was using something besides these one-time use Walmart, or excuse me, China Mart drill bits. Well, it looks like we got it out. Now I'm going to have to hold this together while I pry the rivet out, and then once we do that and get that pressure plate off, then there's not going to be any tension to hold these contacts in place. So this is the part where my butt draws up in a knot. And there's the mica sheet, and like most of them, it's kind of tarnished and ugly looking. Alright, we got the tabs cut off, and I'm going to have to invest in some better cutters. Once again, these one-time use wire cutters from Walmart and China Incorporated are not going to cut it. On something like this, I need something ultra sharp that will cut these things like a hot knife through butter. But I got them cut. I just pray that I didn't break any wires in the process, and we'll know in just a minute. But right now, I'm have fused the plastic pieces back together to give these contacts some stability, and we'll check the continuity here in a minute and hope and pray that they're good. Well, we've got another freaking problem. Try to insert it back in and it won't go back through, because these plastic tabs won't go through the slots here, and that's because this old plastic is all deformed. Alright, we finally got it back in here as much as I can get it. It's not down, I don't think it's down quite as far as it was, but this thing was stuck. It would not slide in, and it was quite a process trying to get this back down in here, but it's in there tight now. Now I just hope the cores will turn if they need to be rotated. And I just checked the continuity. We read 21.6 on one and 21.9 on the other one. Yeah, the problems just keep on coming. So one of my terminals broke off on this IF transformer socket. I was still able to solder this in place, However, during all the beating and banging, all of the plastic I fused together must have come loose, and now the darn terminals are wiggling. They're not wiggling now because they're soldered in place, but that ticked me off. I still have continuity, thank goodness. And another problem is, technically this IF transformer can needs to be making contact with this chassis. I can't solder to it because the can of it's made out of friggin' aluminum. Now the original GE IF would have had a bracket riveted to the can where you could screw it to the chassis. The Miller replacement for the first IF transformer had that. The one they used for the second IF didn't have it, and I guess it worked all these years, so hopefully it'll continue to work. But if I didn't have so much time and effort invested in this thing and money, I would take a sledgehammer and beat this thing into a million pieces and be done with it. And the possibility is still not off the table yet. Okay, I first tried hundreds, and just like with the first IF, I had to back the cores out and still never got as high of a peak as I wanted. So we're going to do just what we did on the other ones. The windings measure similar, so we're going to put 120 and 100 in series, and hopefully we can peak this thing out. So let's see. Looks like that one's at the end, but I'm at the point with this radio that if I can get it working somewhat right, then it can just stay like it is. Well, on this one, the 2 series capacitors, I have to move the trimmers, the cores all the way the other direction to get a peak. So 100 is too high, 58 or whatever is too low. So we might have to go with 75 or whatever. I'm going to try to find out what the model number of that GE radio is that this came out of, and see if by some slim chance they were kind enough to list the capacitance values. Now what I'm thinking as far as making this transformer have a physical contact with the chassis is get some kind of right angle bracket, if I have to make one, and put it here where this clamp is for the dial lamp leads, and then we'll fashion some kind of clamp. I might take the strap off of an old dud filter cap and just put it around the whole transformer and the bracket and clamp it down real tight, and that's about as good as I can do. But this transformer can really does need to make contact with this chassis, and right now it's not doing that very well. So for the time being, the radio is going back together. When I get the trimmers in, we will pull this thing apart and try to figure out what value capacitors we need. I got lucky on the first one. I don't think I'm going to get so lucky on the second one with what I have here to pick from.
In Indiana.
Alright, it's back together for the time being. It's working well, better than it was when we started, but that wouldn't have taken much. But we're just going to have to put this on hold until we can get the trimmers in here and peek out those IF transformers with the trimmers, and then put some appropriate capacitors in place. Now, I should not have gone into this half-cocked like I did. I should have had everything I needed, as in good sharp wire cutters, either some super glue or some 5-minute epoxy or something like that to, yeah, fusing the plastic back together is good for temporary use, but I should have had some epoxy or some super glue or something here to reinforce that so it wouldn't pop back loose when I put it back together. The first IF transformer I don't think did, but the second one did.
Why are you
Now with the terminals soldered in place, it's not going to be a big deal, but we don't need those terminals wiggling around while we're trying to connect everything up, because those wires could very easily break.
Can do more than just mask the pain, more than just 100% drug-free. It's a daily supplement that helps you.
They search the whole world over, study every religion of
Infrastructure with cybersecurity.
from A to Z.
And I still haven't found that little red translucent thing that goes over the...
1-800-for-RELIEF. Visit relieffactor.com, relieffactor.com, relief factor.
See, this is a little bit wide on 1010, so...
I want to tell you about an event hosting in Savannah, Georgia, May 1st, and one I'm hoping you'll attend too. It's job...
And that is an alignment issue.
A couple of days discussing pressing issues.
Alright, radio's still doing okay. Now, I've done some looking, and I found some GE diagrams in the 1952 Beatman's book that look to be close to what I have out there on my junk chassis, but unfortunately they don't give the internal capacitor values for the IF transformers in that set, which is really no big deal, because it's, like I've said before, those values may be a good place to start, but don't take them as gospel, because they may not actually be the best value for what IF transformer happens to be in your set. So we're just going to wait on the tremors to show up. What I'll probably do is set the tremors to about 75 picofarad and just try to bring it in with the cores. We know it's less than 100, but it's more than 58 or whatever, so probably somewhere between 75 to 82 picofarad would probably be optimal for this. And then in the future, when we do any kind of IF transformer repairs, I'll try to be better prepared as far as having what I need to do it. So is probably what I'll do is get some super glue, and when it comes time to glue that top plastic piece back down, we won't fuse it together. We will just put a dot or two of super glue on the plastic and clamp it together and hold it for a minute or two, for long enough for the glue to take, and then slide it back in the case. Now, me fusing the plastic together on that first one didn't give me any problems as far as sliding that transformer back in the case, but as you saw, I had a little difficulty on that second one, and I'm not going to pull that second one back out. It's just too, I think that would be too risky. And we're just going to do what we can do with it in the set. I will devise some kind of way to, so where the metal can will make contact with the chassis, and then we'll call it a day.
Whatever you have to put on a show.
And then probably in a later video, we're not going to do it in this one because it's already gone on way too long anyway. We may, one day down the road, try to come up with a neat way to put that Bluetooth module in here, just to show that it can be done with decent results. Now, whenever I was talking earlier about the hot chassis issue and using an audio isolation transformer, another thing you could probably do is connect the audio ground and the power supply ground together.
This week on
As long as you have all the grounds at the same potential, then there shouldn't be any issues with hum or anything like that. But like I said, this Bluetooth thing is kind of new to me anyway, so we may just have to do some experimenting to see what will work best. But like I said, that's not going to happen in this video. It may be quite some time before it happens. And like I said, I don't have anything right now that even transmits a Bluetooth signal. Now I'm thinking about ordering one of those $22 MP3 players. I mean, that's a cheap enough device that I can use to transmit Bluetooth, but I'm certainly not going to go buy a phone or a tablet or a new computer or anything like that in order to do it.
And Dr. Piper will both say that word.
Now, something else that will probably need to be addressed with this radio down the road, and it's going to be a real, you know what to do, is the tube sockets. As you saw, the rectifier and output tube sockets are very black, which means they have gotten very hot, have been used a lot, and as a result, the tubes are a bit loose in the sockets. Now, I tried retensioning the contacts. That helped a little bit, but the tubes are still loose. It's just the old contacts are just worn out. They don't have the grip that they once did. And this set uses these oddball wafer type sockets that are attached to the printed circuit board, or their version of a printed circuit board. So when that time comes, I'm going to have to get very creative in order to do that. And we'll just have to see how that goes when I'm probably just going to have to use regular PC board mount ceramic sockets and come up with some creative way to install them. But like I said, we'll cross that bridge when the tube sockets in here are so worn out that they no longer make contact. And we do have a little Theta radio here from the late 40s that has a couple of such tube sockets in it, but fortunately that one is a conventional metal chassis wired point to point, so changing those sockets out won't be near as a pain in the butt as what changing the sockets out in this GE is going to be. And this GE was really meant to be a throwaway disposable radio. I mean, what it cost, probably $19.95. They figured get 10 years out of it, and by that time you'd be ready for something else anyway. So generally speaking, when something went wrong besides tubes or maybe a capacitor that somebody could quickly change without having to remove all of that board assembly, then when something more serious than that happens, they just really intended for you to throw it away. So the throwaway mentality is really nothing new, but it has gotten worse in recent years. And just to show you how different things can be, well, I guess this thing's not going to focus, but just to show you how different things can be, our radio originally had 75 picofarad caps in the IF transformers. But if we look at the radio on the next page, also a GE 5-tube set, their transformers use 110 picofarads. So I just really don't think there's any rhyme or reason. I think the manufacturers they just made various types of transformers for different needs, and they use different capacitor values. I know, like for a consumer grade AM radio, their transformers might have been more broad to allow higher fidelity tuning, whereas a communications receiver, where fidelity is not really such a concern, but selectivity is, they would have had IF transformers that were more narrow, and those would have most likely used a different coil configuration with a different value capacitor. So there is no one size fits all as far as a capacitor replacement for these IF transformers. Okay, I have fantastic news. I was digging around out there, and I think I found the little piece that came off of our dial. In other news, I dug up some more capacitor values. We have a 22, we have 33, we have 100, we have 120, we have 250, and we have 330 picofarads available to us. Now, I'm looking at all this and trying to determine what values of parallel or series combination of capacitors we can use to get somewhere between 58 and say, well, less than 100, because we know 100 is too much, 57, 58 is too low. So we can use our 22s and our 33s to get us what, either 77 or 88, depending on how we add them up, and those will be in parallel since capacitance adds in parallel. So we'll try the 77 first. Of course, we'll just make temporary connections, and then if we can bring the radio into alignment, then we will attach the capacitors permanently. Well, I had to come in because it started raining, but here's what we did to allow the IF can to make electrical contact with the chassis. This is a bit jake-legged, but once again, it's not like I can run down to the local parts house and say, hey, Mr. Bob, I need an IF transformer for GE part number so-and-so, and yeah, I got plenty of them, and then run back there and grab it and bring it out to me and I can stick it in here. Well, for one thing, we don't have a parts house anymore. That closed during COVID. And then for another thing, Mr. Bob, and yes, there was a Mr. Bob Sumrall that worked at the local parts house for years. He passed away a good many years before COVID hit. But he was the older fella that had been around since the vacuum tube era, and he knew all the old parts for tube stuff and all that. He's the one that the first time I encountered a blown up bumblebee capacitor, and I thought it was a resistor. I was about 12 or 13. I took it down there and I said, Mr. Bob, I need a resistor of this value. I didn't even know the color code at that time. He said, you don't need a resistor, you need a capacitor. And I'm like, well, it's got a color code on it like resistors. And he said, no, that's a capacitor. And he showed me the blown up innards and gave me a quick lesson on the difference between what the inside of a resistor and what the inside of a capacitor looked like. So anyway, what we've done here, I actually used a part of the radio that's no longer needed, the old clamp for the filter capacitor. I bent it so it will fit somewhat snugly around this IF transformer, and then I cut off a piece of braided CRT DAG ground off an old junk TV, and we soldered it to the clamp, and then the other end of the chassis. I was going to put it right here, but that was a little bit too close quarters, but this should stay on there and provide electrical contact for the can to the chassis. And now let's put our capacitors on the underside and see if we can peek this out. Okay, we were able to peek the bottom one. Now let me get around here while I'll show you. You may not believe me. Turning it in, it gets softer. There's our peak. Turning it back the other way, it gets softer. Now to do the top one, I'm going to need two hands to hold this chassis in position, so I'll cut the camera off for this one.
The church is located at 403.
Alright, there we go, 1450.
Why take a chance? Risk a mistake.
I replaced him in New York, the late great Bob Grant, WABC, used to say it.
And that gets plenty loud now.
Greg Gutfeld, let's Jessica Charles.
And 910, I think their audio level's a bit low, but it's still plenty loud enough.
Specific matters.
Okay, we're back together. Now we'll come back way after dark and do a band scan, but my distance reception, even late at night, is not as good in the spring and summer as it is in the winter, so I don't know how much we'll get, but we'll try. Now, at some point, I will probably order proper value capacitors, because I would prefer to have just one capacitor there on each winding, not three of them in parallel. That just looks kind of ugly, and we need to keep everything as tight and as close as possible. We don't need big parts in parallel, just taking up more space and increasing the likelihood of oscillation or unwanted noise pickup or anything like that. But right now it's doing 1,000 times better than what it was doing when we first started the video.
These are judges, entrepreneurs.
Now, and something else I just now noticed, not like there's anything I can do about it, but the volume control knob shaft is shorter than the tuning shaft, and the reason for that is originally, like I said earlier, this originally had a pull-on type volume control, so when you pulled the power switch out to turn it on, then the shaft would then be the same length as the tuning knob. But like I said, there's nothing really we can do about that right now short of a junk radio with a good pod in it, and I'm not that concerned about it. It is what it is. This is old and cheaply built as some of this stuff is, mainly GE. It's doing good to be working as good as it is. Alright, let's try to do a recap of everything that took place here for those who may have gotten confused, and I can certainly understand how that could happen. Sometimes I get confused myself, and if I get confused, then I wouldn't be surprised if you didn't get confused too. So, we started out with this radio that I bought cheaply off of eBay that was advertised as working great. So I got it in here and fired it up, and it would barely pick up local stations with the volume turned wide open. And then when we removed the chassis, we discovered that sometime way back a long time ago, someone had replaced the IF transformers with Miller replacements. But in more recent years, someone had done a very, and I do mean very, this probably rates right up there with the worst botch job I've ever seen, recap and re-resistor job that I believe I've seen. And if that wasn't bad enough, they added a very sloppy Bluetooth conversion, and this was so bad that some of what they did could have created a safety issue. So we removed the Bluetooth crap for now. We took the printed circuit board chassis out of the main metal pan that it sits in, and we corrected all of that sloppy repair work. We ended up having to replace the couplet in the audio circuit because some resistors in that had gone way off value. I think one of them had gone completely open. We had to replace a very weak 50C5. Both IF transformers, even though they had been replaced at some point in time, we still were not getting satisfactory performance from them. We could not get a peak, so we had to repair those. The first IF transformer I was successful in doing. The second IF transformer, I ended up destroying that, and I ended up having to get another one off of a different chassis that was also bad, but we were able to repair them, and now the radio is working relatively well.
Stage 4 pancreatic cancer diagnosis.
Maybe I should send this back to the guy along with a note that says, if you want to hear what a radio that quote unquote works great sounds like, then this is what one sounds like now. What you had didn't work great. Like I said earlier in the video, that guy was probably either a flipper who bought a bunch of stuff from a collector who either didn't want it anymore, or maybe the collector deceased and the family was getting rid of the stuff, and they turned it on and it picked up a station and they just advertised it as working great. Or maybe it was someone who just did a sloppy job just to get it fixed and get it out the door, and that's all they were worried about, the least amount of time possible. Just give me the money. I think they had this up for a buy it now of like $90, and of course I wasn't going to do that. And they had it up for several rounds and nobody bid on it, which kind of surprised me, because with it having Bluetooth capability, I figured somebody would have gotten moist for that and bid the $90, and then they would have been sorely disappointed when they got the radio and it didn't work worth a crap. And something else that we noticed, that someone had added an audio amplifier module between the output of the Bluetooth and the audio input of the radio, likely trying to compensate for the audio deficiencies of the radio. Weak audio output tube, bad couplet, and like I said earlier, I can only imagine how horrible that sounded. Now I think if we wanted to, we could put the Bluetooth module in here and go straight out of the module into the volume control and probably have satisfactory results. And like I said, there's a good chance we're going to try that one day just for entertainment purposes, even though I've already mentioned I'm not a big fan of adding Bluetooth conversions to these things, but just for entertainment purposes and to try to show others who might wish to do that the proper way to do it, then we might do another video on that. But right now, this has gone on way too long, and I'm just not in the mood to fool with that right now. Alright, we'll wait till after dark, do a band scan, see what we can get. It would have to be better than what we started with, and then we will call this radio done.
It's not.
Okay, now I do want to reiterate as far as the sloppy repair work. You know, if you're a newbie teenager like I was at one time, a long time ago, don't know any better, I can kind of cut you some slack for doing crap like this, as long as you're willing to acknowledge when it's brought to your attention that the way you're doing it is not right and that you need to make changes. But if you're just one of these who knows the proper way to do it but chooses not to do it, all because you want to get in there and spend a grand total of 20 minutes on it versus 20 hours just so you can hurry up and get the thing out the door, then I just really don't have a lot of faith in your abilities. Now, I'm inclined to think that whoever worked on this radio probably did not know a whole lot about troubleshooting. I feel like they probably did know enough to take an ohm meter and check the resistor values based on the, I think there were 2 or 3 resistors in here that were original and were still within specs, so somebody knew enough to do that. But I just get the idea that whoever worked on this thing was one of those that fell into the, if I replace all of the capacitors it's going to work like brand new category, and obviously it didn't work out that way. So, like I think I said earlier, you know, don't do sloppy jake leg crap like what was done to this. Take your time, do it right, and then when it's all over with, you'll feel a lot better about it, and you'll know that you're sending a radio down the line that was done at least halfway right anyway. Now, when I talk about sloppy repair work, I'm not blanketing every vintage electronics repair person in that category. There are a lot of very competent vintage electronics repair people who do quality work, but there are a lot of the other kind who give the good kind a bad name, and that's why, generally speaking, I will not buy a restored piece of equipment unless I know who did it, or unless it's very cheap. And generally when it's very cheap, then you know you can pretty much count on what to expect. However, there are some that charge a high price and do shoddy work. But I just would a lot rather have something that hasn't been overly botched on, or in a perfect world be all original, and I don't have as big of a mess to clean up. Now, there are guys out there that do better work than I do. I'm not saying that my work is top notch by any sense of the word. You've got some antique radio restoration people that they believe in restuffing components and making the set look as original as possible. I have no problems with that. I commend anybody who chooses to do that. I've restuffed caps in a couple of radios before, but for the most part, I'm more about getting the radio playing and keeping the circuit design as close to original as possible. Now, I've got an Atwater Kent 84 Cathedral radio that somebody restored, and it plays good. And whenever I opened it up to have a look, whoever worked on that restuffed everything as it would appear, and I actually had to look very closely to even tell that anything had been done to that radio. That's just how good a job whoever worked on it did. And I was telling a friend of mine about that radio, and he was telling me about his friend and mentor who taught him everything he knows restoring an Atwater Kent 84, and he was that type of person that believed that whenever you restored an antique radio, you should be able to look at it and there not be any immediate evidence that that radio had been serviced. And my friend was like, it'd be something if your Atwater Kent 84 was the one that my friend worked on. And I said, well, it could have very well been, because the guy that bought it got it off of eBay, so it could very well be the one that your friend restored. But as far as the slouchy repair work, something I've seen more than once. People will buy something advertised to be restored, working great, blah blah blah. They get it and it doesn't work worth a darn, and then after a short period of time it doesn't work at all, and then they have to find somebody competent to do it correctly. So that's what you have to be careful for. If you're going to buy something restored, then you should do your homework first, and if the person that did the work is worth their salt, they should provide pictures of the restoration work. If they're not willing to provide pictures, then they probably have something to hide. But anyway, enough about that. This has gone on way too long. We'll do a brief band scan later, and that'll be the end of this video until, if and when the time comes, I decide to add that Bluetooth module to this just for the heck of it. Now I'm going to say one more thing about IF transformers. I keep thinking of new things to say. Probably 30 years ago, my mentor showed me the innards of an IF transformer. I'm pretty sure it was not Japanese, and I'm pretty sure it was not one that had been rebuilt, but it had the brown silver mica capacitors inside the transformer. Now that type of transformer would be way less likely to give problems, and that's the way all of these should have been made. They could have made the transformer just a little bit taller and put real capacitors in the base instead of those mica sheet things with the contacts folded over on both sides. And something else I've noticed, the little Japanese radios, even those little cheapy dime store 5-tube jobs from the mid-60s, I've never encountered a bad IF transformer in one of those, and I believe those have real capacitors in them. So those little Japanese cheapo radios might not have been the best performers, but there were some aspects about those radios that had the American made sets beat, and that they had IF transformers that used real capacitors, and most of them had tube retainers to hold the tubes in the socket. Alright, hopefully I won't think of anything else to say, and we can do the band scan after a while. It looks like we're not quite finished yet. This thing still just wasn't performing quite up to what I thought it should. So I touched up the alignment again, and that improved it. And but the dial wasn't tracking right. And on this set, there's no adjustment on the oscillator coil, only on the tuning capacitor. The better sets will have a trimmer for the low end and a trimmer for the high end, and you have to alternate the two back and forth until you get it right. Well, I was checking tubes, and the 12BE6 converter tube shows a short on 2 positions. So we need to find another 12BE6. Alright, tubes in place. I've got the signal generator warming up. I'm going to go through and align this again. Don't worry, I'm not going to do it on camera, but we're going to align it again just to make sure, because whenever you replace a converter or IF amplifier tube, that can throw the alignment off a bit. Alright,
we're going to close out this
back
edition of
together.
Friends and Neighbors.
WSM is booming in now, but here's the problem. We're having trouble with the dial tracking. I can get it to track right at the lower end, but when you get up at about the middle, it's all out in left field. I can get it to track at the higher end, but when I get down to the lower end, it's all out in left field. So I just aligned it for best sensitivity, and that's where we're going to leave it. Like I said, it's a cheap radio. The better radios would have had either a snug tuned oscillator coil or an extra trimmer in that circuit for the low end, and then you'd have the trimmer on the tuning capacitor for the high end.
Oh man, somebody take the program and knocked out. Actually, the front spirit, other visible element. So Christ uses those churches and ecclesial unity.
I think that's 690 New Orleans.
Incredible. It's moisture in the air because of this.
That's 700 WLW.
Sounds delicious.
But I pass on the fries. I don't need. Now
Let's see, that's 750
we went to Steak and Shake, and I got it because they're using the new tallow oil, and which is far superior than all of the other oils that are out there that we tend to use on a regular basis.
And it's a little high right there, not much.
Yeah, and you know what? We don't. In October, I'm actually the accountant of the Israeli Bob.
Okay, what is this?
2023. Oh, you're what? To the date about Israel, just right.
Hold on, slow down a second. Wait a minute. You're what? With the Israeli what? I didn't hear you.
Okay, that's 840. That's a little high.
As you would say, knock a snot. So from Baton Rouge, Louisiana, Emory Jones Jr. Right.
870 WWL coming in at about 900. It's going to be 890 WLS most likely. 910 coming in at about 950.
Mississippi State baseball from Learfield. For the ones who get it
1010 coming in at about
the one you need now. And the
1060, I guess.
Deliver. That's why millions
positioning themselves this year and next year in the draft.
Schedule your free home energy checkup now at AmoryMissouri.com.
That's most likely KMOX.
Cardinals.
Yep.
KMOX.
Yep.
Well, the Cardinals are back home. Their home record 9-4 overall, 11-15.
Coming in at about 1,200.
Come to your house and have dinner or before dinner.
1390 come in at about 1450.
Fox Sports Radio. The most fearless voice in sports is on FS1. The one and only
1450 coming in at about 1480 or so.
We're counting down the hottest hits in the nation on American Top 40.
Relive the countdown to the biggest hits from the 70s.
What's this?
On Classic American Top 40 with Casey Kasem. All commercial free. And now, there's more. Dive into a second channel just for the 90s and 2000s.
Well, now we're up to our long-distance dedication.
2 channels, 1 legend. All the countdowns you love. Just search Casey Kasem on the free iHeartRadio app to listen now.
Talk Radio 91.3.
Oh, so it's 1510 running Casey Kasem reruns now.
Our scripture and quote of the day, Proverbs 15:22. Plans fail for lack of counsel, but with many advisors, they most likely fall failure. I guess I will start
So if that's 1510, that's coming in at about
$40,000 in debt.
That's coming in at about 1610. And I have the dial pointer set to where it's about straight in that position. And it's about straight in that position. And that right there is what I'm going to be listening to most of the time anyway, so I guess that's about it for this radio, considering the HELL that it's been through during its lifetime. It's a wonder it's even playing as good as it is. Okay, there are a couple of possibilities that you may not be able to notice because this camera won't focus. There's a capacitor coming off of that oscillator coil and tuning capacitor. It is looks like a 47 pico puff, and whenever I was looking in the radio when I had it apart, that looked to be one of those precision ceramic capacitors that looks sort of like an old dog bone resistor. Not exactly, but similar. That didn't look like it had been replaced, and it probably shouldn't be replaced unless it can be proven that it's bad, because those were often hand selected to get proper tracking of the oscillator. But if something's happened to that capacitor, that could be an issue. Another thing that might be a problem, this 22K resistor in the oscillator circuit that somebody replaced. Originally that would have been a carbon composition resistor, but it was replaced with a film type, and sometimes film resistors and RF don't get along too well when there was originally a carbon composition in there, so we might have to go ahead and replace that with the proper type. That's really why I do not like to replace components in an oscillator circuit unless they are so bad that they're causing trouble, because then you have stuff like this taking place. Now, when I get the individual silver mica capacitors to go across the IF transformers and get rid of those series combination caps for the first IF and those parallel combination caps for the second IF, and then realign it again, it might behave better. But we're not going to visit those possibilities in this video. It's gone on long enough. The radio is relatively sensitive as it is, and that's my main concern. When the time comes that we revisit this for the Bluetooth, we might briefly spend some time trying to get this dial to track properly, and if we can't, then that'll just be the way it is. The biggest thing I'm dreading as far as if I end up changing that resistor is I might end up having to pull that board again, and I just really don't want to do that if I can get out of it. Now, the alignment instructions in the SAM say to set the dial pointer to 550, so that would be right there with the tuning gain fully set to that end of the dial. But if I do that, it's way off, so I just set it back straight across like it was before.
The morning rush hour, the evening rush hour, and everything in between.
Slow spots are starting to build up the east side perimeter on 285. 24/7 with the Triple Team Traffic Center.
We've had several breakdowns, including one in the express lane.
Your source for Atlanta's traffic.
95.5 WSB, Atlanta's News and Talk.
As I was saying before, while the dog was going crazy, I don't know what his problem was, so I just set the pointer back to straight line, straight across like it was. And
if you've fallen behind on your mortgage,
in the northwest corner of Highway 190 and 22, or in Metairie on Veterans Memorial.
Well, 1010 has dead air again. And that's that 1010 sports station out of Pensacola or wherever it is, or somewhere in Florida. That comes in when 1010 has no modulation. You can tell the transmitter is running, but there's just no modulation, which is just a total waste of money on their part, and just shows a lack of concern on their part too.
Page report to meticulously list.
That's probably 1070 WDIA.
The paranormal. If you have your statue, and then we can start talking. Well,
for the careers of those 8,500.
And maybe 10 years ago, maybe 70 years ago. Expanded. This is all coming. It's not otherworldly there. He's not
And that's it.
Well, then we tell you how many miles until the next bucket. Now I think actually they get a lot of these.
It's doing about as well as any other
Great.
5-tube radio would do.
So if that's walks out, to talk to one more time. As Connor McDavid puts the
For the day of love.
That's probably 89 WLS.
game if you're watching it on TNT, by the way.
Guys, get it to get some amount of space on.
Cars.com. Congress is poised to pass a bill to keep AM radio in cars, but time is running out. 82 million Americans risk losing the news, sports, talk, traffic, and vital emergency information they rely on. Text AM to 52886 and tell Congress to pass this bill now.
Message and data rates may apply. You may receive up to 4 messages a month, and you may text stop.
If AM ever goes away in cars, then you might as well just slam the coffin on
WSB Atlanta
AM radio, because that's where most of the cars is where most of the radio listening is done today. So I realize there's still many cars on the road that still have AM receivers in them, but once AM disappears from cars and all the older cars with AM radios in them start disappearing, then that'll probably be pretty much the end of AM.
Yeah, Russell Crowe Glass.
And even though I don't care for most of what's on AM these days, I don't want to see it go away.
You know I love a good archaeological story, Deborah, and now I guess...
because it still most definitely has its place. In a disaster, AM radio has the ability to travel great distances and is probably one of the easiest mediums to transmit as well as receive, so it doesn't need to go away, in my opinion.
And it not only showed signs of physical combat, but
give way to dazzling dark skies at the free John Glenn Astronomy Park, and so much more. Find the magic at ExploreHuckingHills.com.
I'm Holly James, and I really want to hear from you, but not now. This is a replay, so don't call, but do call Monday through Thursday nights from 10 to 1, right here on WGN Radio.
Super Duty and Ford Mustang at MikeCastrucciFord.com. That's Mike Castrucci Ford.
When I was little, I didn't talk for a long time. I was sensitive to lights and sound.
Lively and fun conversation, so give us your best clean joke on Monday. Thanks again to our show team, Matt, Michael, and Rich. For Debbie, I am Jerry, wishing you a beautiful and blessed weekend. It is Divine Mercy Sunday, so let us beseech the Lord and soak in His amazing divine mercy.
Major decisions can feel daunting. Do you feel lost and alone? Not sure what
that's 690 out of New Orleans,
may be the right option for you. Whether it's practicing,
which many moons ago was WTIX, the AM Top 40 station.
always at the center.
Today, those call letters belong to an FM oldie station in the area. WSM.
Lean on Jesus.
So for right now, this radio has the balls on the reception end. You just can't really rely on the dial to know what station you're on.
Of inspiration. My name is Jeff Hogue. I'll be back at it Sunday morning with the Gospel Hour from 9 until 10 Central. If you enjoyed that song, you'll really enjoy that program. It's nothing but country gospel, songs of inspiration. And then, of course, we'll get back into it Monday night at 7 p.m. Central with B-sides, rarities, hits, and stories. And I hope you can join me then. Until we speak again, please be safe out there. Whatever you do, please be kind to one another. Keep it locked to WSM, Nashville, Tennessee.
One Saturday night in 1925, George D. Hay invited Uncle Jimmy Thompson to the WSM studio to play some old-time fiddle tunes. And so began an American tradition we now call the Grand Ole Opry. Now, as the Opry celebrates its 100th anniversary, WSM is proud to still...
Okay, this has gone on way too long, so we're going to call it a night. I'm done for now.